right. What is this, day 3? I think this is day 3. Just getting my morning ready a bit. Having some coffee and some bagels. Hope everyone's having a nice weekend so far. Just enjoy the sounds of me eating a bagel. So I'm eating a cream cheese and peanut butter bagel. Let's see. What did we get done yesterday? We got the x-axis complete yesterday. And the z-axis complete. All we really have to do today is so we got to do the LCD enclosure. That's on here. And then get the y-axis assembly and the heat bed completed. And that should be good, I think, before we can really start up. It's sort of looking like a 3D printer now. Oh yeah, that's what I was going to do off stream. I was going to do the test where you pluck the timing belts to see if they are tight enough. But I did not get to that. I was busy doing other things. But I hope everyone's having a nice weekend so far. It was kind of early for most people on the weekend. Because normally on weekdays I wake up at about, what was it, 5:30ish in the morning. So I have to be on the road at 7 a.m. So starting at 8 on the weekends is sleeping in for me. Morning there, Marcus. We're just getting our day ready with some bagels. So I've been buying this cream cheese lately. It's jalapeno cream cheese, and it is so good. It's like lower calorie than the other stuff. But it's like having spicy stuff in the morning is such a weird flavor combination. So as we can see in the upper right, we're going to start with the LCD assembly today. And after the LCD, what else do we have? Then it is the carriage. So 2 major steps left today. So we'll probably be able to get to actually start printing stuff. Before we can start this chapter, check what version of LCD you have and follow the appropriate instructions. That's our LCD assembly there. I should probably do that when my hands are free. Let me put this in the kitchen. All right, all right. Enough yapping. Let's zoom in just a skosh. Put that off to the side a bit so I have more room. All right, so we must distinguish our versions. So the version can be recognized by the location of the PE fasten symbol. Okay, that's a nice looking LCD screen. so it's this version. It's got the PE, or the earthing, whatever you want to call it, here. That's interesting. Putting a LCD, or not an LCD, but PCB onto a flex cable. I don't see that too often. Okay. So version A. For this version, follow step XLCD assembly version A. So we need LCD. We need to remove the protective cover film. We need the LCD cover. So looking at the LCD cover. So LCD cover. LCD support left. Okay, that looks like them. And then reflector sticker. What is the reflector sticker? Reflector sticker, okay. It's a reflective sticker. Okay. So let's keep going. We also need M3x8 screws. So let's see, these are M3x10s. Need 4 square nuts. 1, 2, 3, 4. Come on, not that many. M3x6. We got M3x6. 3x10. Do we even use any M3x8s? I don't think so. Let's see, this should have M3x8 screws in it. Say what kind of M8s? No, just standard socketed cap screws. Yeah, see, I think there they are. This is one of those opportunities that they could try to commonize these ones to be M3x10s. So how many M3x8s do we need? 4 M3x8s. Then a PE fasten is what we need. PE fasten. What does a PE fasten look like? There she blows. That's a PE fasten. All right. Let's go on to assembly. Assembly version A. Version A is what we have. So first we need to do these square nuts. It's my favorite little Knipex miniature plier here. Let's get those started in there. And they're not centered, so we gotta press them in a bit. That was going much easier that way. Okay. Get the couch set up so I don't have to move it around all day. Get the knee cushion. Oh yeah. That's still a little tight back here. Gotta rearrange my living room just to do this. All right, where were we? So do that. Installing the reflector sticker. So we need to peel off the adhesive. Position the reflector strip so that it lines up with the side of the LCD cover. So what is the purpose of this? Let's see, we've got this here. They want us to put the reflector sticker in here. Why the hell a little cut in it? Interesting. Looks like they didn't fully cut it. just finish cutting this. One side and both edges, and continue to lay down the reflector sticker strip towards the other side of the gutter. Press the reflector strip all the way into the gutter so it adheres to the XLCD cover. And this reflector has got a bit of a curve into it, so I don't quite understand, but I shall do as I am told. Alright, seems I've done that alright. Okay. Okay, we've done that. Next, assembling the LCD support right version A. So on this side, got that. Then we hook it in. So this. So this is the one I want. It's got the little hump here. We hook it in. Position that one hole there. Line up the hole with the plastic part, insert the XLCD with the LCD support right. Still hooked on. The support must fit perfectly into the recess. Okay, so we don't put a screw in it just yet. I see. Is this? Let's wipe off this Loctite and get a fresh batch for today. Of course, I spread it onto myself. Okay. So, we want to line all this stuff up. First, we want to peel. Satisfying peel. Come on. Why aren't you going in? Okay. Looks like we have some movement. Don't want to force it. Got a satisfying snap there. That doesn't feel right. Why is this not going in smoothly? Okay, that's feeling better. I'm guessing the board is supposed to be slightly proud. No, the board is supposed to be fully recessed into it. The recess for the XLC to be blah 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 must fit perfectly into the recess. I don't know, boss. That doesn't seem perfect to me. Okay. There we go. Now she fits just right. Make sure to hook the LCD support right holds onto it, otherwise you won't be able to attach it later. So M3x8 screw. We don't need Loctite on this one because it's going directly into plastic. For this, they could have easily made this boss about 2 millimeters higher to use one of the M10 screws. Okay, next, attach the PE fasten on the top left hole of the LCD. Okay. And this one is also going directly into plastic. Make sure it's not going to hit anything. Okay. Position that correctly. Okay. Everything is laying flat and looking good. Okay, next. Left support. Secure both parts together with 2 and 3x8 screws. Okay, so this little guy just fits into there. So also no Loctite on there. Dun, 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 dun. These are just going into plastic, so we don't need to over tighten them. Just tighten them until they bottom out. Okay. So that's good. Nice little screen. Next step. LCD cables. So we need a PE cable. Come on out of there. So we need one of these. We need a ribbon cable. And what else do we need? We need the knob. Okay. Don't hit the camera. It's too early to start hitting the camera already. And what else? M3x10 screws. How many? We got 4. All right, so let's keep going. Connecting the PE cable version A. Stop hitting everything. So my little couch cushions that I'm using, they've got that funky like L angle on it because it goes around the armrests. So every time I try to rotate it, it keeps hitting the table. All right, so let's flip this back over. So we need to connect the cable end here. Does it matter which end? Note the safety latch on the X LCD cable connector. It must be plugged in the side of X, blah, 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 with the slot and the thing. So, normally, Normally with ribbon cables, you look at the tracer. So this has got a red tracer on this side. And that's what you typically look at when you're installing these. So they look to be the same. But I've got one red tracer, and that's what the picture shows. That's what we're going to do. Red tracer goes high. It's not going in very easily. I really would not want to destroy this board. There we go. And that required a bit of a force, but it looks like it's fully seated. Okay. Next, we gotta attach the grounding, earthing, PE, whatever you wish to call it. There we go. And good on Prusa for going with crimped connections rather than soldered. Crimped is the way to go. Now go to step 21, attaching the knob. Common for both versions. Okay, so 21. Piece of junk. Click the go to 21 and it jumped, but it just reset the whole thing. Okay, so got, is there any, I've got a little, there's a flat part in the encoder shaft that blah 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 should align with the flat on the seat knob. Okay. Satisfying little click. Okay. I'm assuming that is done. So now we need to attach the XLCD assembly. Guide the XLCD cables under the front plate. Blah, blah, blah. Okay, so that's what it should look like when it's installed. Let's maneuver everything here. Take a sip of coffee. Trash pile. Where'd my trash pile go? Did I already throw away all the trash from yesterday? I might have. No, I just put it over here. Okay, so that's a Wi-Fi board. Okay, so we want to basically do some yoga while we're doing this. So get these under y'all. Okay, now we can put some Loctite on here. I was really itching to put Loctite on some screws, man. We'll just start that one. Is today Saturday or Sunday? I think it's Saturday, right? Am I going crazy? Because yesterday was Friday, right? Yeah. Oh man, I get a whole other day. Is it Friday still? It's what it feels like for me. Also, morning, Ghosty. Hope you're having a nice Saturday morning. Hopefully everyone is taking enough time to relax and clear their brain of whatever work drudgery they had during the week. How's this thing supposed to... I guess it's supposed to be a little bit proud of the surface. Bit awkward angles on this thing. Gonna have to do the old reach around to get these. Okay. That's just open and flapping in the wind. Home project queue. Gotta love it. Okay, let's keep going. So now we have to route decables. So the orientation of all this stuff did matter. So I wonder where this end goes here. Okay, I see why they split the cable now. So they can package it a little bit easier. So let's put the earthing strap. I always forget. It's like, I think in the UK it's earthing strap. And everybody in the US calls it grounding strap. Or vice versa. And then everybody in Europe calls it PE strap or PE wire. So all that needs to go under there. I'm wondering if this, I wonder what this gets attached to. I'm sure it will be revealed. Okay, and then the ribbon. Well, actually, let's look ahead a bit just to see where that extra bit goes to. Okay, so it looks like we shouldn't have this one in here. This one will be used elsewhere over there. Come on, get in there. Get in there. Okay, and then that also goes under the chassis. Okay. Alrighty. Connecting the PSU parts preparation. So we need PSU cover. Let's look in the Bago LCD PSU cover. Bag done. So then we need M3x10 screws, buddy power cable, do we need any more of this box? Heat bed, no. X-Buddy power cable and power panic. Okay. So let's see. So we got the what is this? Why do I have two of these? 2X. Okay, so I do need two of those. So we got two of those. And let's see, cable ties. So let's see, 1, 2, 3, 4. Okay, and okay, another bag done. Well, we do have a spare reflective strip in there. I won't need it, but I'll put it in the spares pile. Okie dokie. Let's see. Alright, let's keep going. Connecting the PSU PE cable. Place the printer so that you have easy access to the bottom of the side of the PSU. Remove the left screw on the PSU circuit board. Note that there is a washer on the screw. Do not throw the screw away. You will need it later. Place the single end, not the forked end. Yada, yada, yada. Okay. Let's reposition this stuff. Don't think I'll need that for the time being. Make sure this is in frame here without hitting the camera. We don't want to do that. Okay. So, remove the left screw. Wait, did we have any? Yeah, we had two M3 by 10s, our favorites. So I haven't connected any of these in here yet. So I'm just going to keep these out of the way. So, place the printer so that you have easy access. Remove the left screw. This is not the PSU. That would be problem one. X-axis is like right in the way here. Hopefully that doesn't want to shift too much. Okay. So we want to remove the left screw. Note that there is a washer on the screw. Do not throw it away. Place the single end of the PE, not the forked end. So this on here. So then we want to make sure it clears. Need to move this just a bit so I can see it. Hopefully we can both see it. Okay, so that is a Phillips. So let's see, I've got a PH1. It's probably the right size. Man, the terminal is more magnetic than my driver here. Okay. Then I'm not sure if it's clear from the picture or not, but usually the connector here, and it's really hard to see in it. You have the crimp side of the connector, so you want the flat side facing toward the board here. Okay, that's on there. Good and tight. All right, next step. Guide the PE cable so that it does not interfere with the threaded column under the PE connector. Check. All right. In the following steps, we will be connecting the power supply cables one by one. The terminal screws are installed on the PSU already. Loosen them, but do not remove them completely, so don't get them mixed up with the other types. One has a prevailing color, red color equal positive, and one has a prevailing black color equals negative. Note that the power cables have different connectors on each end. For now, prepare the U-shaped connectors. Okay. Blah, 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 max fast, blah, blah. Do not connect any cables yet. Wait until you have been prompted. Okay. So, what they are wanting us to do here, basically wants so you can't see it here, but on the side of the power supply they have V plus, V plus, V minus, V minus. And then we've got red and black, and these do have like I'm thinking this is part of the co-extrusion process that they do, is why we have black and red for one of them. I don't know if that's just because they're kind of cheap that the co-extrusion actually, I don't know, bled over to the other one or something. But normally they're pretty well separated. So we want to, these are pH. Just loosen them slightly. And it's, now you can't see it in the video, but typically when you're using these little forked or U-shaped ones, you've got a little clamp plate on the little screw tower here. So it's the screw, trying to explain this. So you got the screw, and then you've got a little clamp plate, and then the terminal. So you put the fork in between the clamp plate and the terminal. You don't want to put it in between the screw head and the plate, because when you tighten it, it'll start to twist, and you don't want that. So we're going to insert one red, second red, just put it in loosely. And then I don't know if they require these to be sort of paired up so that V1 or V plus 1 and V minus 1 are the same, but I am going to do it that way because that's sort of what it looks like on the picture here. I'm not sure that it matters since it's probably a common rail. And they're probably just splitting it out for, I don't know, current or something. I don't know. I'm a mechanical engineer. Electricity is like magic. Okay, and then we'll tighten these. And one of the, on my YouTube recommendations, I've got something that I've been meaning to watch. It's like where Phillips head was it a worse drive than I think like the square drive or something, and you know, whatever YouTube video essay is talking about. I gotta watch that because I'm interested to see if what led to the rise of the Philips drive, which I'm not particularly a fan of because they always seem to cam out. I would much rather have everything hex or Torx if I had my way. Okay, take the 2 red wires, slide in the fork, blah blah, hit the black wire and slide them in the black. Steel washer above the fork. Yes, we did that. Check all connections again. So, do the wiggle test. I use the wiggle test so much when like diagnosing equipment too. It's like one of the very essential skills you need when you work on equipment or really anything in general. Just the wiggle test. If anything is loose, then just being able to do that is like, oh yeah, that's possibly a problem. You should tighten that up. Okay, and then we need the power panic. They're really adamant about checking the connections. So connect the power blah blah into the PSU. Use the side with the black connector at the end. So got this black connector. So let's see. This is a Delta brand power supply, so it's not a Prusa brand. Would be interesting if they made their own branded version. Oh, that is interesting. Their latest power cables here, they're using crimped connections, but instead of those open ferrules, they're now heat shrinking the ends there. I wonder why they did that. Okay, next we have to insert this. Let's see, these are our screws. So while we're thinking about it, probably use one of these here just to keep it all nice and tidy. Even if it's just temporary, we might actually leave that there permanently because, you know, just cause. Just a dab of Loctite on here. Yep. Get back here. Put this cover on. Make sure everything is going in. Okay. And then let's take the look at the bottom of the PSU, guide all the cables through the cable clips according to the picture. Okay, so we want it to go through. Move these to the side here. You don't have to trust me that I'm doing this. can't really see it. Because I can barely see it. I don't know how you'd be able to see it. Got that X-ray vision. There we are. It's routed pretty tight up there. Not really a fan of this tight bend radius on these, especially on power cables. I'll just leave that there for the time being. I honestly probably would have shifted this up slightly. I know they wanted to use those screws to attach this to the extrusion, but I don't know. Seems like a bit of an improvement they could make. Alright, next. So, guiding the Z motor right cable. Okay, so we're going through here. Oh, they actually have a... Oh, okay, okay. Have to reposition this again. Okay, so as you can see in the picture, they've got two through holes this way, and they want you to use a cable tie to tie this little Z-axis motor cable off. So they actually want it to be tied back there. Oh, it's like double? Oh, that's interesting. I wouldn't have thought to do that. It's a very tight radius. I want to maintain my twisted pair here. So they want it to go through here. Over the cable. Through the other hole. Man, that's a bit janky. Not a huge fan of doing that. Is that even going on the right side? Oh, it's getting all twisted in here. So where is the twist? see, I'm not a big fan of that. Tight radius on a twisted pair. I'll do it, but I won't like it. We'll trim that back. Okay. Cut off the remaining part of the zip tie carefully. Let's see, guiding the power bundle cable. Okay, so they want us to route cables down this way. Is that the interior rail? No, that, yeah, I'm wrong, sorry. They want it to be on the interior side here. Might be. Okay, so let's see what all the wires we got. So we've got the Z-axis cable. Is there a better way to do this? This is... Yeah, I don't want to bounce on that. What can I prop this up on? Can I use my 1, 2, 3 blocks? 1, 2, 3 blocks to the rescue. Yeah. Or sort of. There we go. Prop it up so we can actually see what we're doing. So, we're working from here. Okay, so now you can see more of it. Now they want us to route all these cables from the power supply here, including the Z stepper motor. Capture all of these through here. I don't think it matters which side the head of this thing is on, but I will follow the instructions. So let's bundle the power earthing cable, grounding cable, wherever you might be. Hey, morning Deadpool. Back from your vacation. Well, I hope you had a nice vacation. You said you went on the cruise, right? That's what your vacation was? Okay, my LCD. Alright, that looks like the pictures. Carefully pull the gentile and tighten so it'll snug and holding the wires. Be careful, do not over tighten as it can cut the wires. Yes, that is correct. I agree, Mr. Prusa. I want to keep the Z-axis separate as much as I can, so it'll be up here in the bundle. Not that electrically I think it matters. I'm interested why the panic power is a twisted pair. I wonder if there's a reason for that. Okay, I'm not going to fully tighten those until... Let's see, guiding the power cables. Okay, continue guiding the cables toward the X buddy. Include the Y motor cable in the bundle. Y motor. Oh yeah, this is the Y motor. So we temporarily Velcro zip tied that off just to make sure it didn't get in the way. So let's see. All right, so they want all these cables. Okay, so this is sort of like at a junction point here. It's interesting. So it looks like they've got the thing on its side. That's why it looks a little weird. So the extrusion with this cable should be going through here, which it is. I don't know why they had us hook up that Z axis. Okay, so the next location is this. So they want it to go directly over here. Let me twist this a bit more. Whenever possible, you want to keep your twisted pairs twisted, because the twist actually helps with, I believe it's noise suppression when sending high frequency signals, so your lines don't try to crosstalk on each other. Something like that. Okay, and then we'll install that zip tie. Well, we got to make sure we get all the cables in. Okay, well, let's keep these wires separated. Not that I think it matters too much. Then we bring those together, and then we can loop around. Okay, that looks good. Okay, keep these separated. Right. Snug those down just a bit. I don't want to tighten those up just yet. I want to make sure everything gets to the correct locations before going too crazy with the tightening on these things. So then this, they want that to go over there. Do they have another one? Oh, they've got another one right there. Dang. They really want to keep that sucker strapped down. So they want this to basically not be a part of the bundle. But they do want this to be part of the bundle. Okay. Man. I sure like packaging that stuff tight. How am I even supposed to get that zip tie done? Can I get that zip tie done? Guess I gotta kind of leave that loose so I can actually get in there to cut it. Actually, I gotta move this out of the way completely. Just make sure that it's routed. Or I guess just completely remove that. Then I can get its friend in here. All right, we have contact. All right, all right. Okay, make sure the steppers stay together. Make sure we got the potentials. In there as well. The ribbon cable is passing through. Gently tighten it. Don't full tighten it yet. And we won't put those back in just yet. Because I do need to get my nipper in there to be able to clean those up. Leave the ends of the cables free for now. You got it. They want it to route through there. They want all this stuff to go through there? Dang. I like it dense. Even the power? Okay, even the power. But not the axes. The axes do not go into this cable management. Clippy clip. Okay. Let's just leave all those free. That goes over there. So then they want us to connect the X and Y motor cables. Okay. So let's move our position here off of the 1, 2, 3 blocks without dropping everything. That would suck. Let's make sure we've got this framed where you can see it. Okay. So next we want to connect the motor cables. Cables. Okay, so let's see. This is the, which is this? Oh, how thoughtful they put little labels on these things. Okay, so the X goes to X goes to here. This is where, I'm not sure if it's visible, but they've got a little silk screen letter here to show the location of that. I might need to loosen that thing up a bit. I'll just talk a little bit louder since I'm a little bit farther. So the little clip on here goes this way. So I'll make sure these things stay nice and twisted. Nice satisfying clip. And then Y is this one. Make sure we keep it twisted. Once again, I'm not totally certain on the signal requirement integrity for stepper motors here, but they do operate at pretty high frequency, so it's not a bad idea to keep everything pretty well twisted, just to keep noise, like electrical noise, to a minimum. Because that is one thing you want to avoid, is having noise in here where you miss a step or something and your print goes all haywire. Okay. Gently push down on that to make sure they're fully seated. Okay. So then connect the Y motor cable. Okay, that's what our picture looks like. Next, connecting the PSU cables, parts preparation. So we need 3 more cable ties. So 1, 2. 1, 2, 3. We got 3 cable ties. Yeah, a little rubber band. Then we need power terminal screw, 6/32. I guess there's just some things you can't get away in the world of manufacturing and
for whatever reason, power cable connections are still in imperial measurements. 6:30 seconds. I'm assuming that legacy of imperial measurements with electrical related items is mainly because the US developed so much of the electrical infrastructure in the beginning. Okay, and then we need M3x6 screw, 1. Yeah, see, this is a, let me measure this, just for pedantic sake here. 6/32. That comes to approximately, let's see, 4.4 millimeters. So you could just replace that with an M4 screw and call it a day. But no, you gotta have your imperial measurements with your electrical. Then you get into wire gauge and stuff, and that's a whole thing. Let me refill my coffee real quick. So a note on electrical standards, at least in the European stuff I've worked with, they at least try to do the more logical thing of, instead of using gauges and stuff like that for wire size, what they now call out the wires as is the cross-sectional area, which, I mean, logically makes more sense, but it's less intuitive in terms of identifying something. So it's really hard to identify 1.5 square millimeters versus 1. But as far as nomenclature and actual usefulness, I do believe it's better. Okay, and we need one M3x6 screw. We have that. Our 6/32 screws, and we need one M3 washer. One M3 washer. And 3 cable ties. Okay, connecting the PSU cables. PE cable. Attach the PE cable connector to the right lower screw hole in the X-Buddy box. Secure the cable with M3 washer and M3x6 screw. Tighten the screw firmly. Note the correct orientation of the PE connector. Okay. So, move these to the side. So it wants to be here. That's where it wants to live. dab a Loctite on him. So let's see, we need to route this such that he comes in here and wants to land right there. Oh man, they made the lengths of these things just long enough, All right, carefully, I'm going to put this in here. Maybe Loctite wasn't the right play on there, but so we want to make sure we cleared that hole there. Make sure we tighten it enough so that we get a good contact. Okay, and we're clear of that. And those have stayed clear. Okay. Next, we want to connect the PSU cables. Secure our terminals, verify correct placement of the cables comparing the picture. This is crucial. Okay, so they don't specifically say which one goes which. Again, I'm assuming this is because it's like a common rail type of thing, so it doesn't matter. That's just my assumption, though. That panic power cable is quite tight in there. So this is why we don't fully tighten the zip ties until we have all this stuff properly routed in here, because you don't know when you might need some extra cable length. So let's see, the connector goes like this, I believe. Yep. Satisfying click. Get you guys a little bit more in focus there. Okay. So then we want the power here. Now, as far as curious as I am whether these are common rails or not, I'd want to get like my multimeter to actually test if these are common. I need to resist that urge. Not that it really matters. Because one is for heat bed, one is for power in. So positive minus, positive minus. You know what, actually, I think it would make sense. Let me quickly grab my multimeter, and I'll be right back. That's right, through my keys this way. also brought some measuring equipment. Not that I needed it, but I wanted it because, you know, who knows? Sure, I'll forget that I put my stuff there. All right. Got this. We will turn our multimeter into continuity mode. Make sure, so we get a little beep if the multimeter detects that we have continuity. So let's see, are the terminals are a little filthy, been in the garage too long. So are the heat bed positive and the power in positive common? No, they are not. What about negatives? Are those common? Yes, the negatives are common. Are the negatives common with the earth? No. Okay. So the negatives are common, so the negatives don't matter, their position. But the positives, they're potentially... wait, what? Why'd I get a little beep there? It's interesting. I don't know why I got an initial beep. Okay, so the positives are not common, but the negatives are. So, what does that mean for us? Okay, and the negatives are not tied to that. Are the negatives tied to the frame at all? No, I don't think so. But the earth is, should be. Okay, so grounding is the same. Earthing, grounding, whatever, is the same for like the case and stuff. So if my earthing, grounding, so that connects to here. Yeah. Okay, so since these aren't really cutting into that, it's not technically part of it. But anywhere that our system is cutting through to the bare metal, we should have a common earth or ground. Yeah, okay. All right, so these two positives are separated, but the negatives don't matter. Then does it say which side should be which? Because it doesn't say like V1, V2 should be here or V1, V2 should be here. So I'm assuming, my assumption is that the power supply unit itself has the same output amongst V1, V2, but they aren't common rail. So that's just my assumption. Let's put these suckers on. Oh wait, I just noticed something. I did not put the little washer on our earthing cable. And that normally isn't a big deal because normally you want to use cutting washers when you're doing earthing cables. I think this is probably just to prevent it from twisting while you're tightening. So let's tighten that up. Making sure we clear the little threaded boss there. Sufficiently tighten. Let's pull you in just a bit so you can see more what I'm doing here. So we just got the earthing or ground, whatever you want to call it. We got that in. And then we want to do the V plus and V minus. One is the hotbed, one is the power in. And like I said, there was not a distinction between V1, V2 from here, but the grounding or the negatives are the same, or they're common. So, do I... Let's just roll with it, see what happens. But it'll be one of those things we keep in the back of our head to sort of diagnose stuff in the future, because I don't know if, for whatever reason, V1 might not be active immediately, but V2 is, and vice versa, so. And they didn't have, dang, they did not have these labeled. They're the same part number. Let's not move too aggressively here now. These cables are nice and tight in here, man. They don't give you much room for cable length, do they? I didn't even tighten these things yet. Barely have enough length here, dang. I think these are the same length cables. Okay. I think that's as much as we're going to get out of those. Okay, then these don't really need Loctite on them. I'll just put a dab. Whoops. Split those just a bit more. Maybe it's only Phillips screws that are imperial measurement these days. Okay, just loosely put that in place for the moment. Then the positive, just the ittiest bit of Loctite. I don't know if it's frowned upon or not to put Loctite on electrical connections. I don't know if Loctite is conductive or not. Just loosely put them in place so we have enough length to route those. Split those just a bit more. The littlest bit, because these washers on these particular screws are cutting screws or cutting washers, so they're designed specifically for electrical connections. They actually will dig into the terminal or whatever you're screwing it into, so Loctite is probably not a big deal. So I will take my smooth-jawed pliers here to try to pull a little bit more length out of this. Because it's very easy when you're pulling on a wire to actually break the copper inside. So using a smooth plier will help prevent some of that. Obviously the best case is to not have to pull on it in the first place. But here we are. Maybe I need to swap these. Because this one, I don't like how tight this one is, and this one's got a lot more length. So let's just swap these. Just for my OCD sake. Stay in there. That's why we don't want to tighten them down completely just yet. If you see me rotating the screws backwards, that is not me being an idiot. While it might look that way, a little trick when installing stuff is you do like a quarter turn or so of the screw, and you wait until you hear it sort of slip back into the thread start. And then that means the threads are going to engage correctly. And then you can go the other way. Because what a lot of people try to do is they try to start the thread immediately, and it very oftentimes gets cross-threaded. So doing a quick, like half turn or something until you feel it sort of fall in to the thread helps a lot in preventing cross-threading. Okay, now that these are routed, we can tighten them completely. So you see, as I tighten these, they shift. So you can just brace them a little to prevent them from twisting on you. Not that it's a big deal, it's just one of those pedantic little details, because you want to make sure that the screw is cutting rather than turning the fastener. Okay. Okay, those are nice and tight. And let's double check that other one. That's nice and tight. And we are clear of that. That's good. Next step. Securing the PSU cables. Oh man, they're really all about zip tying that stuff on, aren't they? So these little doodads have some slots for zip ties. So they want this to be zip tied on top of the cables there. I mean, that's an interesting idea. I don't know why. Okay, so this has to go all the way up to here. Is that in frame? Yeah, so let me scooch this over here just a bit more. So they want this cable to route on top of all this stuff and to go to this terminal strip or parallel connector, whatever the technical name is. They want it to go there. So Still haven't zip tied those down yet, because we'll probably have to do some cable management in here just to make sure all this stuff gets routed the way that we want. Let's go back to the thing. So divide the cable bundle into 2 paths. Guide the power cables and power panic cable around the left clip. So they want all this stuff to be on this side. They want to use this. So they don't really want to use this as a holder. They want to use it as a holder for a zip tie is what they want to use it for. Can I even get one of these things out after I put it in? Guess not, dang. So let's zoom in on that. So there is a, right there. How am I supposed to get that in there? It's crazy. So they want it to go, see if that is there. They want it to go in here? What kind of crazy person thought this up? That is ridiculous. I don't know, this seems like a bit of an afterthought. Just trying to take this thing out. Jeez. Okay, so they want to use these 2 holes to secure this bundle here, which I don't get how you would do that in there. That's a bit much in my opinion. And they don't even have it shown correctly in their diagram. They have it shown where this piece is going that way, but in the as installed, it's the other way. Not that I think it matters because it's just a zip tie. So we'll do this. So this is all the cables that we want in this bundle. The panic power, the PE, and the 2 powers. So then we can sort of pre-do that there. Just start that zip tie and then we can put this back in. Will I even be able to get to the thing? Maybe. That's wild. So that'll make sure those stay separate. Oops, sorry about that. Bumping my microphone, getting my coffee. Brain's still not working yet. Still need about 1 million more milligrams of caffeine. I'm not shaking putting this stuff together. That's how you know it's hard mode. and then this, we'll start this. So they want the entire bundle here. Excuse me. Some close-up mouth noises. So they want this whole ribbon assembly to go through there. That's some interesting cable routing. Okay, so I don't want to do that yet, but we can pull this through a bit more. Still keep enough length. So then they want this to go over top here. And man, they've got that routed very strangely. So they've got it going under the bundle and then on top of the bundle. Okay, let's see. So, I don't know if the glare, let me see what it looks like on the screen here. So, it's probably difficult to see, but on this little connector here, let me see if I can occlude the light just a bit. Yeah, so you can see this little connector. Light, go away. Yeah, so this little connector here where I'm pointing with my screwdriver, that little white arrow is what corresponds to your red tracer on your ribbon cable, as well as the this little, once again, light, too much, this little tab on this terminal. So, so I want to do that. Do this. And does everything come through there? Okay, I'm only going to put these in loosely, because the way this will come in here, probably have to fold it over a bit like that in order to make that turn. Unless, is there a way I can flip it beforehand? No. So either that way or that way. Kind of like the idea of doing it like that. So that is how I will route it. Doing a 90 turn. Does it look any cleaner? No, it doesn't look any cleaner doing it the other way. Okay, and we'll only loosely put that in because I don't want to fully tighten those down until we have everything connected. Because like we saw before, we'll probably run out of length where we need it. Secure all cable paths with the zip tie to the cable clips. See the detail showing how to push a zip tie through the clip. And then they want us to do the other Z-axis, that same crazy way. It's where it is. Going through here. Which side? They have the head of the zip tie going over there. Like so. Once again, don't fully tighten it until you need to. Kind of get why it costs how much it does for assembly. Dang, this is a whole ordeal here. Okay. Do not over tighten the zip tie. It may fatally damage the cable. Oh, fatally damage. Okay, so then they want us to connect all the stuff. Okay. So the LCD connector. Along with the bundle. Okay, so that's interesting. They're basically, I don't know if that's like a hack or what for electrical stuff. So they're essentially having us wrap the ribbon cable over the twisted pair stuff. Is that like a hack to do shielding without actually having to do shielding? Or is it just lazy? I don't know. Okay, so we do our 90 flip-a-doo. Let's pre-fold that a bit. So I much prefer doing it this way, only because I remember seeing in very old computers and stuff like that, ribbon cables were folded at 90s or 45s, whatever you want to call this. And I never really saw them sort of like stretched very long ways. So that's kind of what I'm basing my assumption on. Okay, that went in. Not very satisfying click though, but it went in. Could tighten those a bit more to keep them out of the way. I don't know, it's such a hacky way of doing this. That's like we're essentially making a shield from a ribbon. But hey, if that's what they say, then that's what we'll do. Another thing, going into sheet metal with zip ties and then trying to tighten them, you're always sort of fighting the zip tie self or getting cut and caught onto the sheet metal itself. Okay, that's one. What a pain in the butt. Well, the bikers are out on Saturday morning. Everybody loves their Harleys around here. I'll tell you what, Bo. I don't know, one weekend there was like a Harley convention or something, and it was like a constant drone of motorcycles going for at least 30 minutes while they were cruising around. It's ridiculous. Okay, so we've got our pseudo shielded cable going here. So once again, I'm not going to fully tighten it until we get everything where we want it. Yep. Do not over tighten the zip ties. Yeah. Connecting the extruder main cable. Connect the extruder main cable to the slot in the right side of the X-Buddy. Arrange the cable according to the picture. Tighten the cable bundle with 2 upper zip ties. Do not over tighten. Okay, and then we've got this bundle. Oh, you turkey. So we weren't supposed to do that one just yet. Oh, gosh. Another reason why I hate zip ties. Excuse me, cable ties. Because if you do something too soon, it's really hard to reuse it. But it's also a reason why we don't over tighten these, or tighten these until we're done. Because, if possible, you're able to use a little thinner slotted screwdriver to actually disengage the ratcheting mechanism in there. So you can loosen these, but it's like such a pain to do that, you know? It's like in automotive wiring, they don't use zip ties as much as possible. They will use a sort of cloth type tape to wrap their like body wiring harnesses and stuff like that, because tape is much cheaper than a zip tie. Even though zip ties are cheap, tape is much cheaper because it comes by the foot or the roll or whatever. There we go. Jeez, what a pain. So they want us to lay this over here to go over this to here. Kind of how you doing here? So the connector body itself, we've got these little connectors there. So we want to put that in. Satisfying click. Then, doesn't really matter, but separating out the twisted pairs from this bundle. So we want to make sure that when we're putting stuff in, like connector-wise, you don't want things to be pulled to the side. You want it to try to have a nice strain relief on it. So once again, I don't think there's going to be much more going in here. You've got one connector there. I think that's for the extruder or something. No, that's for the y-axis. No? What is that for? That's for something. Oh, I gotta stand up for a minute here. In mil-spec wiring, what they do is at cable connectors, what they'll do is they have what's called a service loop. So a service loop is when it's coming into a connector like this, you'll actually see each individual wire is twisted like this. So it's a little loop-de-loop. So a little loop-de-loop. So hopefully, it's probably too small. Yeah, so they'll have something like this. It's hard to see, but it's a service loop. So you actually loop the cable at the individual terminal for each terminal. So you'll see, you know, these just, if I can grab another one here. And I'm sure I'm not doing this the correct way according to mil-spec or whatever, but you'll put a loop in, and then all these loops are turned into the connector. So what those essentially do is make the end of the connector more flexible, as well as gives you a small length of wire. So if for whatever reason you have to replace the terminal in one of these connectors, then you have enough length to cut the wire, strip it, then recrimp it and put it back in. So that's the purpose of a service loop. But we are not doing mil-spec wiring, otherwise we would be here all day on a single connector. But all I'm going to do for this is just make sure that when we come in, it'll be a nice gradual turn in. Because we don't want to put strain on our connectors. So just a nice swoop. Come on, zip tie. Quit fighting me. I want to make sure that bundle stays on top of the other bundle. Not that it matters other than just being pedantic and trying to organize it. There we go. Okay. So I'm not gonna over tighten that zip tie, at least tighten it fully yet. Make sure that connector is fully seated. Take a drink of coffee. Might need another one of those. All right. What do I need to do next? The others. So don't get that caught in anything. So I got that. I kind of want to have this go behind these here. So we'll disconnect that guy and route him behind these. And I don't mind having it do a loop-de-loop here. Okay. Make sure, so that's moving. Okay, so most of these have pretty good strain relief on them. This one has enough for a loop. This one, that's pretty good. This one, that's a little too tight. I need to make sure that this one, so once again, why we do not tighten all these things before we get to the connector, because we might have to be pulling this through the entire harness. So I want to make sure that when we're coming through here, yeah, you can still see that. Maybe push this over just a bit. So we want to make sure that when it's coming in here, it's not being pulled anyway, and tries to go as straight down as possible. Okay. Okay, I'm happier now with those. So then I can put this in. Let's separate those, not that it really matters. Get the little itty bitty screwdriver in here. Once again, I'm fighting the sharpness on the sheet metal to get that strapped. Okay, and then that gives us enough here to have like a little loop-de-loop, which I'm happy with. So we can push him into the corner. And the loop probably should be the other way, just so when this screw goes down, it's not constantly rubbing against stuff. Because even though it's not technically moving, since this thing is going to be vibrating a lot, anything that's touching parts or screws or sharp edges will eventually rub through. So when possible, you want to make sure that things are clear of fasteners and sharp objects. Even if they're just touching, the high frequencies and vibration will eventually rub through stuff. So that's more important in critical applications. Like this is not critical at all, but it's important. I'll say it like that. Okay. Okay, so we got to a gummy bear. Okay. So Next is the Y carriage and heat bed assembly. So before we start this, let me clean up my area, put away my multimeter. Organize my screwdrivers. Don't need that little guy. All these here. Blah, 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 blah. What am I doing? What am I doing? Coffee. That's what I need. Coffee. Clearly, I'm not caffeinated enough. We are at the right temperature for the coffee now. Is like at prime chugging temperature. Okay, so first we're doing the heat bed. So let's look through this quickly. So I got some cables and stuff like that, yada yada yada, and bigger stuff. So we will, how do we want to frame this? Okay, looks like it's going to be prep work without this in the way. So I will gently move the assembly. And then, is this going to be too big or too small? So here's the heat bed. Okay, we probably need to zoom out just a touch. Yeah, that looks good. Reposition here. Don't hit the tripod. We'll try sitting Indian style for a minute. Reposition the microphone here. Okay, so we need to prepare the heat bed cable. There's that little guy. So, heat bed cables. Stick. Need M3x10 screw, our favorite. So 2 M3x10 screws, 2 M3x10 washers. Okay, so that means this can go in the spares pile. So 1, 2. Okay, and this goes into spares land. So I've got so many spares. I mean, that's not showing all the the graveyard of spares over there. So I got that, 2 washers. Then we need M3N nuts, so nylon locking nuts. Nuts. Where are those nuts? Okay, those are normal. M3N, those are normals. Let's put these back in here. We are looking for nylon lock nuts. Don't you fall out of there. It's such a mess over here. M3 square nuts. Where are those? Did I put them back? Maybe. So let's see, we got power terminal screws, set screw, countersunk screws. Okay, they are not in there. Spares. More spares. Empty bag. Rubber pads. That is not a rubber pad. Oh, that's the bad one. Where did I put these locking screws or locking nuts? Those are square nuts. Long. 3x6. Those are standard normal. Here they are. So how many do we need? We need 2 M3N. So 2. So those don't require Loctite. Even though technically nylock nuts are not meant for higher temperature stuff. I think they are slightly higher temperature than Loctite, because what does Loctite say here? It does not say its rated temperature, but I think it's like maybe 150 C for Loctite that it goes up to before it breaks down. Okay, I can put this to the side. Okay, so heat bed cable assembly part 1. It is important to connect the power cable correctly before you start the assembly. Have a look at the pins. The one on the left with GND sign must be connected to the black wire. Take both heat bed cables. Note the label on each cable. For the following steps, prepare the ends of the cables without the label. So, no. Yes. So, I mean, technically, these should be positive and minus, not ground. Actually. So, let's open this. Ooh, shiny. Man, that's a thick PCB. I think that's like 10 layers of fiberglass. I'm curious. Oh, it's magnetic too. It is a 4 millimeter thick fiberglass PCB. Dang. No, wait, 3 millimeter? Is that 3? 1, 2, 3. Yeah, 3. Still, that's a. It's also magnetic. That's a beefy board right there. Okay, so we want to connect these cables. So not the ones with the labels, because those will probably melt. So socket head cap screw washer. Put that assembly in there. And then the nylock is on the opposite side. Okay, okay. I mean, usually you'd put a washer on the opposite side of that as well. But we will not be picky. We will follow as instructed. Okay, so I'll just finger tight that on. And be gentle with that board. Washer. So the main purpose of washers is to make sure that the torque and rotation of the screw is transferred as tension into whatever it's bolting to rather than rotation. So if we were to not have a washer on there, you would see that this would slip as you tighten it, which we don't want. Okay. So we'll use our fancy schmancy little Knipex parallel pliers, which I love. Hold that tightly. And what is that? 2.5? No, that's a 2. 2.5. I guess I could do this left-handed if I was really worried about it. Just for the shot. Just finger tight. And position that before we make it finger tight again. Yeah, so those are nice and parallel. So let's see, attach the nuts, tighten slightly, turn the heat bed back around using the universal wrench. We will adjust the cable position later on, therefore do not tighten the screw too firmly yet. Okay. So my big brain predicted that. Oh, that's interesting. Before proceeding further again, double check the cables. The cable cover, blah, 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 blah. And we did not use the ones labeled with the QR code. The cable cover, which will be applied later, requires the connectors to be slightly inclined towards each other. Press them gently, but leave a gap between them. Now tighten both screws firmly. Okay, so they want them to be like so. Okay. So they want them to be like that. And now we can tighten them. Tighten them. Okay, now they're nice and tight. They're inclined towards each other. Okay, I'm happy with that. It might have been hard to tell since we're so far away. But with that washer there, even though I was on it pretty tight, the terminal didn't rotate as I was tightening. Okay, we shall continue. Cover the heat bed cables part preparation. So first we need the nylon thing, 2 by 380. 1. Heat bed cable cover bottom. Not here. Okay, heat bed cable cover top and bottom. So that looks like this guy. Yeah. And this guy. Yeah. And M3 by 10, our favorite. We need how many? 3? Come on, come on, come on. There we go. Come on, get in frame. Don't be shy. And then M3N nuts. Okay, so those M3N is normal. We need 1, 2, come on, 3, come on, 3. There we go. So we got our 3 there, 3 there. Okay. So 2. I think that's the wrong picture. Oh, we also need the. What? Am I dumb? Oh, that thing. The 2 by 380. Yeah, okay. So this nylon piece, so I'm assuming that's what they're going to use for the thingy. You know, the thingy. Okay, assembling the heat bed cover bottom. Insert 3 M3 nuts into this guy. Insert the nut. No, stay. Okay, we'll use our 1, 2, 3 block to press these together so they're flush. Not sure the flushness really matters all that much, but I'm going to do it anyway because I want it. to be perfectly flush. Well, maybe we can't get it perfectly flush. Come on, get on there. Get on there. Okay. That's probably as good as we're going to get it. They'll probably sink in a bit more as we tighten them. Okay. So, assembling the heat bed cable cover and nylon filament. Okay, so place the heat bed cable cover bottom like in the picture. Insert the nylon filament into the hole. So let's see. So insert the nylon filament into the heat bed cable cover bottom. So like that. Don't let the nylon filament stick out too much on the other side. It should not protrude more than 2 millimeters. It goes in here. They said no more than 2 millimeters. Well, we want to be accurate, so let's get out the calipers. So 2 millimeters. There we go, 2 millimeters. Orient the curve of the filament as shown in the picture. Okay, so they want the two. So they want this curve going that way towards the bed. And I can only imagine the amount of like little 3D printed assembly fixtures they have at Prusa in order to do this efficiently. So I'm going to route that. Does it have it coming up between these two? Betwixt said cables? Get through there. So they have it going through betwixt said power cables. Make sure that doesn't protrude more than 2 millimeters. So then the curve goes towards the board. Then we slide the cover under the heat bed cable connectors. Okay. Not okay. Why does that seem like that nylon thing is not the correct orientation? Because they want the curve to be going towards the board, which it is. Okay. I'll take your word for it, Mr. Prusa. Okay. Easy does it. So this is going under the board. So I shouldn't have that heat bed. I think that's the thermistor or something. So that goes under the board. I mean, do I even need to hold that there? Jeez, seems like a pain to do that. So the nuts go into said hole there. Why does that not feel right? What is going on here? I see, sort of. So it's like the board is kind of pushing it down. Or it's interfering with the nylon thing. So that's probably what they were trying to show there. So because it needs to be protruding approximately 2 millimeters maximum, you bend it down. That way it will sort of get crushed under the board, which, all right. Okay. Okay. Put a dab of lactate on that guy. Okay, so yeah, stuff getting in the way here. Okay, so that looks like it's protruding about 2 millimeters. I'll buy it. And then it's sort of getting crushed under the board, which I think is what's supposed to happen. I don't know. I don't do a good job of making that clear. When inserting the nylon filament, ensure it does not damage the thermistor cables under the printed part. Yeah. Slide the cable cover on the bottom, secure the nuts, make sure the nylon filament is still bent upwards as the previous step. I mean, that's kind of hard to do, man, because it's like interfering, but okay. Okay, cable cover top. Wrap the end of the cable bundle together with the nylon filament in the textile sleeve. Slide the sleeve as far forward as possible towards the heat bed as possible. Attach the heat bed cable cover to M3x10 screws. On the bottom side, leave a slack on the thermistor cable for one finger to be pushed through. Okay. Got it, got it, got it. You got it. Oh, I don't like that design at all. Like this, that should be a hole there to tighten that. Because as it is now, that kind of interferes. the nylon filament here. So I'm bending down the nylon filament so it's as flush as possible. And then I can tighten up this piece a bit more so that's nice and flat. Okay, that looks better. So I'm not pinching anything here. It's nice and flat. Oh, holy balls, I didn't realize how many freaking magnets. These are all, on the bottom side here, these are all magnets, holy balls. That's a lot of magnets. Hopefully you can see that, yeah. Look at all these magnets along here. Holy crap. I guess that's how they get that thing to stay on, the little PEI sheet. Make sure I didn't pinch this guy. Looks good. Okay, now we need to use the textile sleeve. Need to caffeine up for maximum fidgetiness. It's like the perfect temperature. Damn it. Okay, so that should go over that. So we want to embed the cable into the textile sleeve enough so that we can slide it without it falling off here. We don't have to do the entire thing just yet. Come on. Okay. Good, 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 good. Everything is like that. Then we need to slide this in as much as we can. Then we're going to be sort of crushing it together. So I want the thermistor cable to sort of be above that, so the lowest part would be the thing, you know? The thing. The nylon filament. So they said you wanted about a finger's slack in the bottom of the thermistor cable here. So about that much. Okay, and then add our cover. Okay, dab a lactate, and that's probably a bit much. Share it with your friend here. Damn it. I said share. Share it. Share it. Give. Good. Dip. Dip. What's going on here? Is that even into the screw yet? I don't know. Meal prep day. Nice. Usually Sunday is my meal prep day. I think doing meal prep is probably the best thing I've done to maintain my diet, because it is so easy to fall off your diet if you don't have anything ready. Those cables are kind of tight in there, if you ask me. Oh, you've been on the road for a week? I gotcha. You go anywhere fun? Ooh, global. A global meeting. For me, and whenever we went to see CEOs, or it was a quote-unquote global meeting, it was mainly just a party. That's all it was. There's a reason for all the engineers to meet again and be like, oh, hey, let's go to the bar, let's catch up on stories and see how you been. And if your boss or manager was cool enough, they'd go out drinking with you. And you'd all be hungover for the meeting the next day. But that's automotive. I don't like how tight that thermistor cable is in there. $10-hour day and then bar night. Yep. That's how it goes. Man, that is tight. I'm not a fan of how tight that is. Let's reposition that a bit more. Maybe we can get the thermistor to be buried in here. Yeah, see, that's How does this strain relief look? If it goes in there. So let's go in from the bottom. And then have the thermistor in betwixt these. So that when we tighten down on it, only the nylon filament and the power cables are the ones getting squished. Because I don't know. I guess we can look at the board here. Well, okay. That might be an easily replaceable thing, but you've got a big piece of Kapton tape and aluminized tape, I believe, and the thermistor is just taped to the surface of it. So replacement-wise, you don't need a full board, which is a pretty good idea. So I don't have to be too overly concerned with it, but I would rather not damage my thermistor before I even get to use this thing. So let's route that betwixt those. Slide the textile sleeve. Come on. Okay, so it's a very delicate balancing act here to do this right. So I want it to lay like right in there. Come on, come on. Okay, I think that got it. Need just a little bit of slack under here. Okay, let's try that again. Hopefully the thermistor is going to be loose enough to where we can still pull on it a bit. It would help if I had the right driver. A little squeaky squeak. Okay, yeah, that feels better. We can still pull on the thermistor cable, so that means we aren't holding it as tight, which is what I want. Because it's not like a thermocouple cable where it has a junction in it where if you accidentally bend thermocouple wire too tight, that junction resistance can increase, which will throw off your reading. So, you know. Okay. Good, 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 good. So then we need to wrap the textile sleeve. Finish wrapping the cable bundle in the textile sleeve and twist the sleeve, not the cables. Got it. Let me reposition my legs before they fall asleep. Legs sleeping. Hard to move. Get. Come on. Don't kick camera. Oh, there we go. Oh my gosh. Let's polish off this coffee here. Maybe there's still a bit of coffee. Oh, stretch these legs. So then we want to wrap the sleeve, not the wires. Can I get under there? Don't drop it. Get in there. Get in there. Twist the sleeve, not the wires. Get in there. Come on. Don't be a pain. I mean, I get that this stuff is really good, but dang, it's a pain in the ass to use. For more production level equipment, we would use a thing called cat tracks. They're basically a molded plastic chain that had a little flip cover on it. You would lay your cables into said cover, close it, and then it had like little articulated joints in it. It's very nice stuff. Expensive, but worth it for higher end equipment, in my opinion. It also restricted the movement of the cables to a single axis. Whereas this, it's a textile sleeve plus a nylon filament to try to do the same thing. I mean, it's cheaper, kind of does the same thing, but it's like, man, what a pain in the ass. There we go. Make sure the sleeve is twisted, not the cables. Kind of want to rotate it the other way. So the curl, the textile sleeve is basically like that. When you're twisting a textile sleeve, you want to twist it so that this part of the textile sleeve is twisted, because if you do it the opposite way, this little piece is going to curl into the wires and sort of like flare out. So twisting wise, always twist it like that. That way it won't catch wires and it will help sort of self-flatten itself. Okay, so the wires are not twisted. Well, they're twisted a little bit. You know, as good as we can get it. Okay, next, coffee. For the following steps, please prepare bearings, carriage, clips. Actually, before the next step, I need to do some liquid transfer. quiz. People were not meant to sit for this long. Dang. All right. So stand up and get up and stretch if you haven't already. We're close to 4 hours already. Thought we'd be a little bit further along, but I'm gonna blame that wire management for taking longer than we expected. Okay. So I can set this aside. Where, I don't know. Don't have any freaking room left. Alright, so we need this. Blame the E, normally their fault. Yeah, I mean, your ME and MEE teams have to work together to be like, hey, I've actually got to route the wires on this thing, even though it, shows in the schematic. We got to actually be able to get in there. Okay, so we need bearings. Okay, 3 MLM8UU. So we need these 3 bearings. 1, 2, 3. Then Y carriage. Then bearing clips. Do we have bearing clips in here? Yes. And then rubber bearing pad and plastic bearing pad. I think that's all the rest of the stuff here. So we got a timing belt. Heat bed expansion joints. We do not need those yet. So we're not fully done with that bag yet, but we're close. 2 bags left in there. So let's see, we got 1, 2, 3, and 1, 2, 3 rubber pads, and then 1, 2, 3 brackets, and 6 M3x8 screws. So 1, 2, 3, 4, 5. Okay, we've got a stray screw somewhere. Is that, what is it, M3x8? Let's just double check these. Yes. Also, if you don't know, on calipers, just these normal calipers like this, you can use this backside here to measure the length of stuff with a positive stop. So you've got this edge here and this edge here. So if you put like a screw like under the head, you can put it there and do that to measure it. So you don't have to try to use these little inside measurements or these pieces here to try to measure the length of something. You can just use the back side of the caliper to measure it. So that is 8. Maybe it's just the angle here, but this looks like it's a little bit too long. Okay, that is indeed correct. Okay, so let's get these out of here. Three by 8. That is done. So 1, 2, 3, and then 1, 2, 3 rubber pads. Then we need the rubber bearing pad. Okay, we got the M3 by 8 screws, 6 of those, 3 bearing clips, and then what else was in there? So we got these extra pieces in here, so we'll make sure those stay safe in there. Okay, lubricating the bearings. Bearings pre-lubricated by Prusa will be in a blue bag, which they are. So we just need to cut these out. Oops, don't drop them. If your flush cutters are able to cut thin packaging, you know they're still good. Like I don't mind people using my tools, but if they don't know how to use them right, it's such a pain. Like these, it says für Plastik on them, so don't use these for cutting, wires or whatever, because these are supposed to stay nice and sharp and flush. So if you're able to cut something as thin as like a plastic bag like this, it's just one go, and there's no jagged edges. But if you start cutting wires with this thing, thinking it's like a pair of side cutters or something, then you're gonna get like holes and notches in here, and so that when you try to go to cut something, it leaves little jagged bits and whatever. So if you let people use your tools, make sure they know what they're for. Okay. Blah, blah, blah. Lubricating. We don't need to do that. Don't need to do that. Assembling the bearing clips. Okay, so it is screw. Oh, weird. Rubber. Plastique. In that order. So screw, rubber. I get they had to do this for the stamping to look good, but it's a pain in the ass. Plastique. Screw. Come on, get in there. Okay, screw, rubber, plastique. Okay, we got those 3. So installing the bearing on the Y carriage. Note the 3 pockets for the bearings in the Y carriage. Start with the side with the 1 pocket. Start with the side with the 1 pocket. Okay. Start with the side with the 1 pocket. Insert the bearing into the bearing clip. Got it. So the alignment of these are important. So let's just clean the edges of those up so we can put a small permanent mark on them. So we want the cross of these bearings to be that way. So that is going to be the up. Not that it matters too terribly much which way is up, but you get the idea. The orientation of said ball bearings, linear bearings. Well, they're linear bearings, but they have balls in them. So they're they are linear ball recirculating bearings. So they are not roller bearings. Okay, so they said to start with this side. We can actually put a dab of Loctite on these. Dabby dab dab. Damn it. My plan backfired. Ugh, it's a little gross. Don't need that much Loctite. Only balls. Okay. Just wanted to dab it. Just start those. Okay. Not thrilled with this thread engagement here. Oh, I see. God, not a fan of that. So the way these little bearing caps are made, they've got a cutout here, which one makes it difficult to get the screw in square, but then 2, they specifically designed it so the head goes into that surface there so they could get it closer, but man, that makes it such a pain. I feel like that could be done better. Just go ahead and start these, because if you're not careful, these will not start in your threaded holes correctly, because you think they're supposed to be like outside of the bearing housing. Okay. So we want that to be that way. We want it to be equal outside there. So let's orient. So our little mark here. So I want to have the same distance out. Make sure our mark is in the up position. Not that the precision of the up mark is super critical, just that it needs to be up. Just lightly tighten this in place. Make sure our alignment is good. We can eyeball that. Let's see, the correct orientation, blah, blah, blah. Make sure the shown in the picture, align the bearings, blah, blah, blah. Maintain the bearing position, slightly tighten both screws, just barely to maintain the position and orientation. We'll tighten the screws firmly later on. Okay, installing the bearings on the Y carriage, attach two bearings and pocket clips, orient the bearings as shown. Okay, so same orientation. So these bearings need to be spaced equally. Okay, so it looks as if... Okay, so I believe the casting here will help capture the linear bearings. Swap sitting positions here. My foot's not going to sleep, then it's getting a cramp. Gotta love it. I'm wondering how much of the design work on this happened during COVID, because I know Prusa was very busy during COVID, just doing a lot of face shield printing for all their local hospitals and such. I'm wondering how much design iteration happened on this printer during that time frame, and if any of these design decisions were sort of a holdover from that, just because parts availability was low. Because sometimes design decisions under duress, well, they work. They're not always ideal. But some of those changes do stick after the fact, just because it's like, well, why change it? Because it works and it's commonized something. But not always. Okay, the bearings must not touch the edge of the pocket. Maintain the bearings position and slightly tighten the screws, just barely to maintain the position and orientation. We'll tighten the screws firmly later on. After securing the clips, double check that the correct position of the bearings so that they do not touch the edges of the pocket. So... got a little gap there. Okie dokie. Let's keep it going. Y-axis smooth rod holders. So let's see. Need Y rod holders. Four Y rod holders. One, two, three, four. Then M3 by 10 screws, our favorite. How many of those do we need? Okay, we also need M3 square nuts. M3 by 10. Yeah, M3 by 10. And then we need the smooth rods. Okay, so we need 12. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12. Almost perfect. Then we need 12 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. I meant to do that. Totally meant to do that. That's just skill right there, man. Okay. So inserting the smooth rods into the Y carriage. Using a paper towel, wipe the transport oil from the surface of the smooth rods. Now, please be very careful. Gently insert the rod straight into the bearings. Do not apply too much force, and do not tilt the rod. In case you manage to push out some balls from the bearing by accident, please count the balls. With 1 or 2 balls, the bearing will continue to work. If there are more of them, please consider ordering new bearings. Tighten screws on each bearing clip. After the final tightening, the movement of the rods must be smooth. Got it. Got it. So let's take off the transport oil just so we can put grease back onto this. There's not that much on there. I think it's mostly to get the debris off from the cardboard box that these were shipped in. And normally those would be shipped in like a plastic container like the linear bearings were, instead of just an open cardboard box. Okie dokie. So they want us to do these first. They don't want us to mess with these just yet. I should have made that a separate step instead of preparing all this. Carefully insert. No missing balls. We do not want to miss balls. Carefully insert. Should not force these through. And voila. Easy peasy. Okay, so now we need to position these because they moved just barely when we inserted these. Okay. They look to be equally spaced. Tighten the screws on each bearing clip. Okay, so we want to make sure that's centered there. And it looks to be. And make sure that's centered. Make sure that's centered. And then the orientation didn't change, so yes, we're still good there. Okay, that's not very smooth. We could probably do a better job of making sure those are even. Yeah, I mean, feels pretty good. If the smooth rod moves stiffly, loosen screws and repeat the procedure. Oh, yeah, that's smoother now. Yes, 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 yes. Not as smooth as it was before. It's still pretty smooth. Okay, yeah. Feels good. Okay, preparing the Y rod holder. So we can place this aside. So then we can take these. Okay, take one take one Y rod holder and insert two M3S nuts. Make sure they are pressed all the way in. You can use pliers, but be careful not to damage the 3D print. Insert one nut from the side of the Y rod holder. Ensure to adjust the alignment of each nut with the 2mm Allen key. Okay, so each one of these takes 3. Okay. So we go in. Let's see. So we have one in here, one in here, one in here. Got it. You got it. Where's my little pliers? Ugh, kind of hard to use pliers when it's on a curved freaking surface. Use our little flashlight here to verify the position here. So that one can be pressed in just a hair more. Because I'm basically looking for the shiny portion of the nut to be in the center of that 3D printed hole. And then we can also use just a normal driver that's smaller than the inside to make sure that it's going to be in the right position. Could be a little bit better. Okay, looks good. Stay. Stay where I put you. All right. Get in there. Get in there. Okay. 2 more to go. I feel plenty caffeinated now to where this is this is hard mode. Got the caffeine shakes. Okay, that's in far enough. That is not in far enough. Good. Good. Okay, good. 4 down. Okay, next step. Mounting the Y-rod holders. Push one of the Y-rod holders onto the rod. Align the front surface of the plastic part with the flat surface of the rod. Check the correct position of the Y-rod holders. The screw holes must be facing up towards the center of the Y carriage. Okay. So these little parts have to be facing in. Then it doesn't probably, the accuracy of that probably doesn't matter, but I've got my 1, 2, 3 blocks, so I will make sure they are flush with the surface. Okay, so they are flush. They're pointing in. Okay. Next step, installing the Y carriage. Hey, what's up there, Technos? We are assembling the 3D printer I bought. And this is part of the Y-axis of the 3D printer over here. So you can see on the top right, we got some instructions. Yeah, legit. It's you know what's written on the tin. We're doing the thing. So we need to make sure the 2 bearings are on the left side. So this is the left side of the printer. Need to move some stuff around. Make sure you can see all the stuff that we're doing. Okay, that looks pretty good. Okay, so they want the 2 bearings here to be on. Oh, you like my little mouse? This is my Logitech, what's this? M570. This is my favorite travel mouse. And it's just a little ball mouse. And it works perfectly for tight spaces. And it's, you know, it works great. I love it. It's just it's got a little Wi-Fi dongle with it. So if you're limited on space, but you still want something that's still ergonomic enough, I love the M570. Okay, where was I? Make sure the wire and fix them with the M3 by 10 screws on the front plate. Tighten both screws equally, but not completely. You got it. Okay. So, this basically sits like so. How nice. Let's get a little bit more Loctite out here. Put some screws in here first. And we will do these. Come on, line, please. I'll use the driver here to align it. No, that's not it. Come on. There we go. Align those things a little. Just want to loosely align everything. Oop. Don't fully tighten it down just yet. Okay, we'll flip this around without hopefully knocking anything over. Oh, camera. Touched out. Can you still see that? Yeah, you can still see that. Okay. Put these in here first. Then we'll do our little technique of aligning that. So we can get that started. Then align this one. And I'm schmoving now. Okay. So I've got all those in. Secure the second pair, blah, blah, blah. Tighten both screws equally, but not completely. We will tighten. I can't read. That would be Back 1 second. Oh, I need to stand up, take a stretch. Oh. Alright. Back. Okay. So let's see. Where were we at? We were tightening these things. So let's see. There are 2 pairs of the screw holes on the left and 1 pair on the right. Secure each Y holder rods and fix them with the M3 by 10 screws on the front plate. Tighten both screws equally but not completely. Insert the Insert the M3 by 10 screw into the hole in each front holder and tighten them. So I'm assuming when they say that, they want this one to be tightened. So they want this to be tightened completely. Okay. So they're saying to screw these in completely first. Before we tighten these. Okay. So aligning the smooth rods. Move the Y carriage back and forth across the entire length of these smooth rods to align them. Then move the carriage to the front plate and tighten all the screws. I mean, that feels pretty smooth. little rough at the front there. So move it back and forth, make sure it's very smooth. Then move the carriage to the front plate and tighten the screws. Then move the Y carriage to the rear plate and tighten the Y holders. Okay, I mean that feels pretty good. So we're just gonna go ahead and tighten them. Can't see them, so I'm going by feel here. The classic Leslie Nielsen's saying, I was going in blind, so I was like a blind person at an orgy. I'd have to feel this one out. Damn it. ¿Dónde está screw? Still nice and smooth. So now we will tighten the back. I'm actually going to walk around here so we don't have to move the whole thing again, even though this area is just littered with boxes. Does not even start. What's going on here? Get in there. Oh, did they fall out or something? Did they fall out and I not notice it? I think those square nuts fell out or something. Ugh. Slides like a guillotine. I don't want to sit down on that. No, those square nuts are still in there. So what's going on? Why is it not going in? Did I grab the wrong length screw or something? greasy. All right, let's try this again. Okay, that's nice and smooth. Ooh, yeah, that's nice and smooth. I shall rotate this. Very carefully. Not hitting too much stuff. Ooh, yes, that is smooth. I like it. I'll just make sure these are tight. Ooh, yes. Very nice. Very nice indeed. Okay, so let's double check the tightness of these. Oh yes. Oh yes. Very nice. Very nice indeed. All right. Next. Y belts parts preparation. Let's put this to the side. Okay, so need to prepare those pieces. Y-axis. Okay, so that's these guys here. Printed parts are not the same. Empty bag. All right, so they're not the same. Arrange them like they are in the picture. With oval hole. Hexagonal hole. So we need an M3 by 40 screw. And it's by 30. How many of those? one. M3 by 10, our favorite. We need 4 of those. 1, 2, 3, 4. And nylock nut. Come on, get out of there. Nylock nut. Then a GT2-20 pulley. That would be this. Then H8 2.9 by 20 pin, but not that piece yet. So this still stays in here. And we need the timing pulley. Not completely done with this yet. Pulley, or belt, excuse me. Another bag down. Okay, assembling the Y belt holder. So the one with the hex nut. So this one. That looks like our picture. So we want this in here, and this in here. Just a little guy. He's just a little guy. Using the screw pulling technique. Few turns is enough. Do not tighten the screw. Pull the nut all the way in. Don't forget to remove the M30. Oh, wait, so we're just using to pull in? Okay. So this is not actually part of the assembly, it's just used for pulling it in. And how far? Oh, so it pulls in fairly far. Oh my. Okay. So we will use that later. I don't know how later. Okay. Assembling the Y belt. Lean the printer on the right side to the one with onto the right side, the one with the PSU. To gain access to the bottom, push the pin into the pulley and center it. Shrip. Okay. Take one of the Y belt ends and push it into the Y belt holder. Is that the one with or without the captive screw? Okay, so that is this piece here. F1. Insert it so this goes into here and crushes that. Okay. That's pretty good use of 3D printed parts. Basically, it's a interference fit, so that is going to push that over to clamp the belt into there. Good use of design features. So which side does the teeth go on? The teeth go on this side. Make sure we embed that as much as we can. I don't think it has to be sub-flush, but we want it to be at least flush. So it's nice and flat there. So that matches our picture. And one thing before I put the Y belt on, I did notice while I was looking at this here, so I noticed that this wasn't quite level, so I'm going to take the opportunity now to do that. What am I interfering with here? Yeah, so I noticed it was tilted sort of like that. Yeah, it might be better if this was the reference. I can't get in there. Maybe the back. State. Okay, I think that's as good as I'm going to get that squared up. Because I was noticing that this thing was sort of like tilted like that. I mean, with timing belt, it's not going to matter as much when you're tilted this way, but you want to get it as good as you can, given your limitations here. Just trying to find a reference surface to make sure you got that square. Is kind of difficult with all these curved edges. Okay, we'll continue. Okay, attaching the Y-belt holder. Use the M3x10 screw. Fix the Y-belt holder to the Y carriage. Use the left rear hole in the center part. Okay, probably more understandable if I get this in the right orientation. So they said put it on its side. Make sure you can still see this. A bit difficult to see. What if I just turned it all the way upside down? Z-axis down. So we can do this, so you can really see what's going on here. Then I'll use my 1, 2, 3 blocks to prop this up. Like that. Okay. Yeah, now you can see what's going on. So using the M3, we have to tighten this guy first. To tighten the timing belt into the little block here. That looks flush. I think that's as flush as I'll get it. Probably even sub-flush doesn't hurt too much. Okay, so pre-screw the screw into the Y belt holder before attaching it into the Y carriage. What? So it seems like the orange side is that way. So I want this going towards the back. Is that? Oh, I think I understand. So they want us to put this in before that's kind of how you doing. Because while you put it in there before, how are you supposed to get to it? Okay, so they want this pointing towards the rear of the machine. Okay, so it's kind of holding on that away. Just a dab of Loctite on there. That is not a good design. Come on. Get into your hole. Okay, that looks like it's going to go in. So it's got like a little lip on that thing to press against the casting. Take the free end of the Y belt. Okay, so they want it to go like this. Like so. Okay. And that other piece we've got right here will be on what? What will that be on? I'm assuming, oh, I see. So that hooks onto there, goes through the pulley, which will rest there, and onto here. I got it. So let's tighten this all the way. Come on. Okay, that's as tight as I feel like making that one. I don't want to strip out the casting because that would be bad. Okay. So then this will go around like so. And it will hook in this way. Yeah, don't have my 1, 2, 3 blocks available. Okay, so it's pushed into there so that once it is routed through said pulley, it'll sort of rest like this with the pulley in here. Okay, so before we do that, we have to put the screw into here. Put the screw into here to lock that belt in place. So it is critical that that is flush or sub-flush because this sits against the casting. So we don't want that to protrude at all. Just a bit more. Okay, good. So that goes around, comes around, goes there. Oh, I see how this is going to work now. That is kind of clever. I will admit. They tell us to secure. Okay, next, set 32. Yep, so they're doing as I expected. Yeah, okay, so that's kind of clever. That's a clever use of multi-part design. So, remember that very long screw that we pulled this nut through with? That actually will go through this part and help tension these two members together to help tension the belt. So it's a neat little design. So while I'm thinking about it, let's put a dab of Loctite on this one to go into the casting. Then we'll also take the pulley, loop that around there, and put it into this holder. That is a design challenge, though, there. Okay, so does it reach? Okay, so we'll have to, oh man, what is that? That's about 4 millimeters difference, it looks like. So we'll have to remove these and let's see, what does it say? If the screw does not reach the hole, it is necessary to remove the Y belt holder, the one already installed, and reposition the belt by one tooth. Attach the Y belt tensioner to the right front hole. Do not over tighten the screw, which is the exact position later. Yeah, so how much further do we actually need this to go? I'm assuming that this doesn't actually need to go fully flush against the part, because if it goes fully flush, then you can't actually tighten the thing. Oops. Come on. What are you doing here? Getting in my own way is what I'm doing. Because this does have a slot in it. I think we can adjust it by one tooth. So let's take this out. Put this pulley to the side. So we'll let me reposition briefly. Oh man, 5 hours. I thought we'd be done by now. This isn't going to be another 10-hour stream. I know that. Okay. So we want to take that out. And loosen this up. Oh yeah. Listen to that screw ASMR. And then we will position this one tooth back. And being a GT2 belt, that means the pitch of the belt is 2 millimeters, which means we will gain 2 millimeters distance. Make sure it's flat in there, just so we maintain our belt parallelism, even though it's not super critical on a timing belt system. Well, actually, I take that back. It is critical on a timing belt system. Probably thinking a V-belt or something. Because with timing belts, I believe it's this axis that is important to have aligned. Oh yeah. Okay, just making sure that it's as flat as I can get it. It's not a completely flat part, but just make sure that's flush or subflush. Okay. So let's make sure that we didn't screw it up. Oh no, that looks good. Not a fan of the orientation of this thing. Just a dab of Loctite on the end of that thread. So how am I supposed to tighten this? Howdy, Theric. How you doing this wonderful Saturday? So how am I supposed to tighten that? Okay. Oh, training fighting, eh? Nice. That sounds pretty fun. What exactly kind of fighting do you practice when you're doing that? Hand-to-hand combat? Broadsword? What is that? Claymore? Current character fights with a basket-hilted rapier. Nice. So are you like proficient with classical fencing and stuff like that too? Vaguely proficient. Okay, most of your training was in kendo. Okay, cool. It's really neat. Come on, get in there. Man, I don't want to damage this thing. Within temptation? Maybe. Yes, it is. You are correct. Man, I don't want to damage this. Oh, my favorite. Said pop right out. How are you supposed to get that in without damaging this thing? So you gotta go quite a far ways. Maybe I'm just doing it out of order here. A buckler? I've not heard of that before. So you're mostly healer, so you don't do too much fronting. I gotcha. What exactly is a buckler? Small round shield. Okay. I gotcha. Oops. mess that up. Maybe it would help if I put this in first. Sort of draw them together, maybe? I guess I could read the instructions. This is probably right in front of my face. Trying to guillotine my hand. Empty bags everywhere. Not a particularly common style. I gotcha. Reminds me of that meme that was going around like maybe a week or two ago where it was some medieval fighting thing, and someone had this very, very tall shield that was probably like 3/4 of their height, and they were defending, and they just walked up to their opponent and just shield smashed them. Everybody was memeing on that. It was pretty funny. Attach the white belt tensioner to the right, front hole, keratin secured with, do not over tighten the screw, insert the M30 screw, blah, blah, blah. So I should have that M10 screw in. Yes, tell me how grass tastes. That one. I thought that was hilarious. How are you supposed to get that in there? Come on, get in there. Okay, that feels like it's going in. Doesn't feel great, but it's going. Over tighten it because it needs to slide just ever so slightly. Okie dokie. Oh, get up and stretch. Okay, that is done. Move the Y carriage all the way back to the back using a finger on the left hand. Push the belt down with medium force. Should be needed to squish the belt until both parts touch. Do not try to overstretch the belt as you might damage the printer. You can change the belt tension by adjusting the M3x30 screw. So, feel like that's good. After you set the correct belt tension, tighten the M3x10 screw on the bottom Y belt tensioner. I mean, I feel like that's pretty good. That's tighter than the other one, and I think the span is similar. So really the only thing, when you're tensioning this, you have to think about the members that it's attaching to. So right now it's attaching to these members here, and when you're tightening this, you're not just tightening this, but you're also making this bow in. So you don't want it to be so tight that you're bowing these surfaces. It still travels very nice and smooth. I'm happy with that tension as it is, so I am going to tighten and get my freaking driver in there. Nice and smooth. That's good. That's what we want. It's in the title. It's a 3D printer. But thanks for lurking and watching. Yeah, so I'm not going to do the belt tension check, but essentially, if I had a analyzer on my computer, actually I might, I don't know, I'm not gonna do it though, but I put the mic really close to the belt, and when you pluck the belt, it's supposed to have a certain frequency based on the tension. So that's what the little app on your phone would do if I had it installed, which I don't yet, but I'll do that off stream because the inspection and calibration part will probably take much longer. So aligning the Y belt, make sure that both the top and bottom parts of the belt are parallel directly above each other. If not, the belt position, blah, 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 blah. Release both screws on the pulley. Tighten most screws, okay. I mean, we made sure to be pretty careful of how we did that. It looks quite good. So I'm pretty happy with that. Okay. I'm going to leave that as it is. I'm happy with it. So then, installing the expansion joints. Must be these little guys. Okay, still got one part left in there. So these look to be, what are these, steel? No, those are extruded aluminum expansion inserts. Okay. Then we need M3x6R screws. I don't think I've taken any of those out yet. M3, 4, M3, 6R. Arr. Yarr. Okay. bag down. And then how many of these do we need? We need 8. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 2, 4, 6. 8. Okay, so we got our 8 screws. Put those to the side. And then preparing the expansion joints. Install the 8 M3 by 6 R screws into the outer holes on the Y carriage. Do not tighten them completely. A few turns are enough for now. Okay, so we can flip. We can flip this thing. Hopefully without damaging anything, because that would be bad. Alright. Nice and smooth like. Oh, my hip is cramping. Gotta love it. Got to love it. Okay, so they want us to take these M3 by 6R screws, place them into these holes here. Okay, so what is the driver for this? Oh, it looks like I accidentally touched the screen. Oops. It's a 5-sided. Okay, so it looks to be a T8. T8 feels pretty tight. Okay, put a dab of Loctite on there. We do not need to completely tighten them. Got it, got it. So hopefully this bed does not get hot enough to undo this Loctite, because that would be bad. Okay, so it's just in the outer periphery. We don't need to completely put them down. Okay, next. Slide the expansion joint from the side of the M3. Needs to be done carefully. It is crucial for the correct function of the printer. Carefully read the instructions. Slide the expansion joint from the side on the M3 screw. Make sure the expansion joints are correctly oriented. There's a recess with approximately the same shape as the expansion joint. The joint must fit into the recess. Maintain the position and tighten the M screw using the 2mm hex key. Proceed for the same for the rest of the expansion joints. Got it. So they slide on and must be captured by that feature. Not this way, but this way. Like so. Okay. So then it says to tighten the M3R screw. So I'll just slide those on. So this is a good use of, so these were aluminum extrusions, and it's a fairly complex shape, but these are just a single aluminum extrusion. They just chop off a bunch of them, and then they do their little cuts and stuff in there. It's a good use of different manufacturing processes. Because with the volume they're doing on these things, these are probably very cheap to make. Loosen that just a skosh. Right there. So they are all roughly in place. So then we can tighten these. Make sure they don't pop out. They're just M3 screws going into an aluminum casting, so we don't want to over tighten them. Make sure it's into the slot. Just go over them once more to satisfy my OCD. OCD's nuts. You got it. Okay. So we got all those expansion joints on here. We can go to the next step. Attaching the heat bed parts preparation. We need M3 by 4 BT. That is these? Yes, those. And then a spacer, which is this guy. So that's another bag down. Another bag down. Then we need a M3 by 14 BT. So that's one of those. Oh, that fastener bag is getting pretty low. So we just need one of those. So that is now a spare. And then we need 8 of these. So 2, 4, 6, 8 with one spare. That goes in the spares pile. Okay. So, put the heat bed, place the spacer onto the Y carriage and align it with the hole in the center. Put the heat bed on the Y carriage and secure it by the M3 by 14 BT. Do not fully tighten the screw yet. Then insert all of the other ones. Okay. Okay, got the heat bed. Okay, just wiping it off a little. So which way does the bed go? Okay, so it's facing us. This is a delicate operation. Probably want to put a dab of Loctite on that. Did I get it? I think I got it. Wrong driver. Okay, and do not fully tighten it. Okay. So then we want to align all these. Okay. So, since these are going to get hot, I don't know how hot this heat bed is supposed to get. There's not much on there, so. I will go against my instincts to Loctite these. Because if they're going to be getting hot, then they're most likely going to degrade the Loctite that I do put on, which will make it useless. And since they will get hot, they'll also expand. So I'll probably have to just regularly check on them or something. I don't know. So one thing with these countersunk type screws is when you use them, they all sort of fight against each other on flat plates like this. Because essentially all you need is, I think, 3 of these to fully locate a part. No, maybe it's 2. But anyway, since they're a conical shape, they will lock the part in 2 axes. So if you have one that locks it in X and Y, but not the rotational axis, so then you put one more in, then that locks the rotation. So having multiple countersunk screws actually over constrains it, and it can warp things. So you have to be careful with your tightening sequence, or just avoid using countersunk screws like that. So I'll not fully tighten these just to get them started. Just lightly put them in place. Next, tightening the heat bed. After all the screws in place, tighten them in the following sequence. Center screw. Then these 4. Then the last 4 corners. So they have at least thought about the sequence of tightening these, because it appears they also understand that these can cause over-constraint on a flat part. So first, tighten this just very gently. Gently but firmly. Okay, whatever that means. So then, so it doesn't say. So we'll go in a clockwise order here. And just go back through them again. Gently, not too tight. Because this heated bed will expand. Because even though fiberglass has really good coefficient of linear thermal expansion, it still expands. So as this expands, really the only thing that will stay in place will be the center, because this will uniformly, or ideally uniformly, expand in X and Y. So that means these outermost screws here will get the most tension. So you'll see basically bowing like this in the plate if we were to put a dial indicator on here when it was fully warmed up. Okay, next, guiding the heat bed cables. So we need the heat bed cable holder, 1X. And 2 M3x6 screws. Yeah, man. So one of these. And then our infamous, where'd they go? That was M3 by 6. That was M3 by 18. So M3 by 6. Need 2 of those. You mean Vertigo? I hate those too. Where are my silly Imperial screws here? They are in this. So I need to get 6 30-seconds terminal screws. And 2 of those. Ah, we're getting close. Getting close. We only got like 3 or 4 bags. Okay, so we've got all our hardware. Guiding the heat bed cables. They go into where? Into the buddy box? Is that? Okay, I think I need to look at this side. Oh, stick onto a magnet or something. We'll rotate this. Oh, yeah, she's getting chunky now. So we're routing these cables. Yeah, it's getting freaking heavy. Don't hit the camera. Okay, and these go. Where's the holder going? The holder goes on the outside here. So it'll probably be easier if I put this on its side. Man, this thing's getting heavy. Okay, yeah. That is a good position for it. Reposition my microphone. So we need to put these through here. So that little nylon nubby nub also fits through there. So how do they want that routed? Okay, so that will route like so. Okay. So the thermistor cable goes here. A little satisfying click. You'll be walking and you'll just feel under your feet and feel off. Oh, yeah. Yeah, I don't know why. That sometimes happens to me too. So we want it to go over like this. I don't know, it might be a inner ear thing, maybe. I'm no doctor. Okay, so just a little dash of Loctite on these. So heat bed minus positive. Yeah, see, they aren't being consistent. On the heat bed, they said ground. But here, they say heat bed minus. Which is less twist. And doesn't matter. So we want to make sure these are oriented in the downward direction. Double check here, it has plus on this side. Don't fully tighten it yet, just gotta make sure those are position we want them. So you do tighten these fairly tight because you want the washer on these imperial screws to cut into the connector to make a good bond. Because when you're talking about high current wires, any internal resistance on any component will heat up that area. So making sure you're cutting into the connector is very important. A lot of the times they will actually specify a minimum torque required to actually insert bolts like that to actually make sure you're cutting into them. Okie dokie. Okay, so then the heat bed cables will be this little guy. Yeah, I didn't know that One Punch Man theme song was on my playlist. Ooh, I missed one thing. One thing I missed. The little nylon cable has its own little hole it can go in. Got its little home right there. Okay, so they show it protruding into the case. And then, when we put the cover on, we want it to do that. dokie. Okay, that moves smoothly. Okay, and it stays out of the way of the print area, it looks like. Verify all connections once more. Okie dokie. This feels like the Animaniacs thing. So we've got x-axis motor, x-axis, y-axis, z-axis. So we're rotating these little wire labels so I can actually read them. The ZR. So ZR. Okay, so ZR. Oh, ZL, ZR. Got it, got it. And then LCD cable. It's on there firmly. Then the extruder main cable. It is connected. The panic power cable. The PE earthing cable. Double check that. And then PSU cables. Verify the tightness. So PSU, panic power, and heat bed power cables, heat bed thermistor. Okay, that looks good. And they look routed approximately the same. And let's make sure all the board mounts are also tight. Okay, those are all tight. That's good, nothing is fouling on anything. The case bolts are also nice and tight. All right. So then we need to install the ESP module, parts preparation. We have the Wi-Fi module, and then we need one M3x6 screw. Ooh, box done. Trash pile. Okay. One M3x6 screw. These are kind of laying all over here, so I will measure it quickly. Yep, get back here. And 3x6, yes, so that is correct. And then Wi-Fi cover. Oh, they didn't put the little Wi-Fi logo on it. Just wait, is the Wi-Fi logo copyrighted? Do people have to pay royalties to use that on their stuff? I don't remember. So Wi-Fi cover. Oh, so then that module goes on the back here. Okay, so they want it outside of the box. I'm assuming they do that so the Wi-Fi signal is not obscured by the shielding of the box. Okay, comes in a little parts tray. Oh, 1 second. Before we do that, I'll be back in just a second. All right. So where were we? Yeah. So this little case packaging here, this is actually what they would use on a reel for pick and place machine. So this would actually be a long roll of these things, and they would actually have a pick and place machine visually identify it, pick it up with a little suction cup, and then place it onto a board before it goes to solder. More packaging. Okay, so secure it with one M3 by 6 screw. So the cover, not the module. Come on, get out of that case. Show me your secrets. Okay, so that little guy right there. Install it into the little terminal on the back here. Just a dab of Loctite. And I'm already running out of Loctite again. Okay, and then we put the little Wi-Fi cover here. Okay, so that little cover is secured. Nothing feels binding on it. Good. Okay. Okay, so then covering the box, we need 4 M3 by 6 screws. 1, 2, 3, 4. Then we need this cover. It's another bag emptied. then EL box cover. Is this it? Yeah, this guy. Then 2 M3 by 10 screws. Where are my M3 by 10s? 3 by 10s. How many of those? 2. 1, 2. The Wi-Fi logo is copyrighted, but you don't know if people pay royalties for it. Well, I mean, if it's copyrighted and if it's from, you know, a major company or something making a product, they most likely will pay those royalty fees just so they don't have to deal with any lawsuits. Same with like the was it the, once again, I can't remember if it Bluetooth is a copyrighted logo because it was sort of like a combination of the old Nordic symbol for Bluetooth. So I don't know if that one is technically copyrighted or not. Let's put away some of this trash. Okay. So, this cover needs to have those M10s pushed through them. I'll dab a little Loctite on these. Okay, dokie. Okay. So then this cover goes here. What? Oh, into these screw holes here. Got it. Okay, so before I can do that, I have to trim down these zip ties since we're finally done enough with this organization that we can clip these. Always make sure when using flush cutters that they successfully made the zip tie flush. Otherwise, next time you go in here, your hands will get cut up by the sharp zip ties. Sorry, cable ties. So now I can install this bit here. So I need to make sure that we push over the panic power so that it doesn't get in the way. Move that a bit too much. Let's try that again. This is just a plastic cover, so I don't need to over tighten it. Just make sure that that is clean and flush, which it is. Nothing is fouling there. Okay, so then we put on the cover here. Those are the, let's see, so goes like that. So that's where this becomes important, of tightening that down, because we've got a little notch in here to clear these cables. Okay. Voila. Share some of that with your friend here. Just a dab will do you on the Loctite. Don't need to flood it. And this is just a cover, so we don't need to tighten it too much, just enough to keep it from rattling. Because since this is a high frequency device, we will have things loosening up over time just due to vibration from one frequency to printer movements. Okay, so that's not going to rattle. Next step, assembling the double spool holder. So we used one of these parts already on the enclosure. So ours is only a single-sided. Assembling, don't use excessive force during assembly. Got it, got it, got it. Assembling the filament guide. Let's see, bag empty, bag empty. Oh. Okay, filament guide. I'm not sure we'll be using the filament guide since we have the enclosure now, but we'll still assemble it. So I could probably, I'll just put this out of the way for the second. Yeah. So let me rotate this briefly out of the way. Okay. Okay, so the filament guide. Got that, got that. So this, easy. Next, we've got filament guide. Another bag, empty. So then, we need filament guide. 2 PTFE tubes. Yes, Girl DM did finish Signalis. She got the best ending or better ending. She got the what was it? Promise kept or whatever. So let's see, M3N nuts. Okay, so this has its own little assembly here. So 1, 2, 3. And then M3 by 10, so it's using its own. So I think this was an optional thing that they just threw in there. And 1 M3 by 18 screw, but no spare of that. Okay, so now all these are spares. That can go into the spares pile. Okay. So we need to insert 2 M3 nuts into here. I think the playthroughs are still up on YouTube as well, if you want to catch the VOD of them. Because I think she finished in just under 3 hours on stream after chatting in the beginning. Okay, then PTFE rings. Fix the tubes in place with 2 M3x10 screws. Okay, those are in. Fix the tubes in place with 2 M3x10 screws from the other side. Insert the third M3 nut into the opening on the side. Okay. Okay, so then where does this go? Well, this goes on this guy. Oh, I see, I see. I'm following you. So it's gonna sit like an aerial or a mast or whatever. Hmm. Oh, does it? So it really only fits in the top position here. All the other ones are slightly too small. I wonder if that is by design or if that was a oopsie. All right, so then that's it. Okay, so next is going to be a bunch of checks. So before we can do that, so I can just put this to the side for the second. Man, we got a lot of spare hardware. I need to flip over the printer so we can finish the thing, you know? The cable management. That's a spare, that's a spare. That can go into the box pile. single-handedly keeping the small plastic bag industry in business. Dang. Okay. Is that a stable position? Yeah, I guess that's stable enough. That's surprisingly stable. So we need to clean up some of these cables. I think I'll probably take this off. And we can tighten these. Tighten these, make sure they're not too tight. And we need to route these into this cable guide here. Do kind of question why they need to be so tightly spaced there. That wasn't a clean clip. I'll be all right. A meltdown over a zip tie not doing the thing. Okay, make sure it's flush. Okay, that was a clean cut. Get this in here. Clean cut. Don't want to over tighten that. Clean cut. And we can put this into here. Okay, that goes in there. Make sure that's good. All right, then we want to, let's see, we do want to attach all of this here. I guess this can be a little bit closer over here. Not too tight because we can accidentally cut these. Yeah, so in their instructions they showed the incorrect orientation for that because otherwise you would not be able to get to this zip tie to clip it. It's nice and flush. I did that one. So I want this to be approximately here. make this freaking difficult? Jeez. Shouldn't be that freaking difficult. Come on now. Separate those. Sort of continue this hokey shielding here, I guess. That's nice and flush. Okay. That's flush, 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 flush. Did we have any more zip ties? Got those, got those. Then we had those in there, we did those. It's nice and smooth, so that's good. Everything, I believe, is tight. We tighten that, tighten that, tighten that. Tighten this, tighten that, tighten these. I think we're good. And everything is moving very smoothly. Zoom out just a skosh. So, looks like everything moves smooth. Okay, what is left here? Attaching the steel sheet. Oh yeah, we gotta attach the steel sheet. So because this was the anniversary edition of the Mark IV, it came with 2 of these smooth PEI plastic sheets here, and the anniversary one was this disassembled version. So let's see, how do they wish us to align this? So we've got those 2 screw threads that we align it to. Okay. Keep the steel sheet clean for optimum performance. On the sheet by the 2 front corners and slowly lay it down into the heated bed. Watch your fingers. Keep the steel sheet clean for optimum performance. Number 1 of cause of prints detaching from the print surface is a greasy steel sheet. Use IPA, isopropyl alcohol, to degrease it if you have touched its surface before. We are using a steel sheet with a smooth surface. However, the same procedure applies to other variants. Okay. So I have touched this. It's a little greasy, but they have generously supplied a little isopropyl, a 2,2-propanone sheet to clean it. Man, that's on there well. Okay, that looks thoroughly degreased. I guess you can use both sides, so I will clean both sides. Also clean this other one. Just standard smooth sheet. Okay, it's got a little greasy fingerprints on it, but we'll leave that to the side. I'll have to get some more of these sheets. They dry out very quickly if you do not keep them in their little packaging. So another bag down. Okay. So firmware update. Ooh, firmware update. Wizard self-start. I mean, a lot of stuff in there. Okay, so before we start updating firmware, navigate to the original Prusa page. Ah, okay. Okay, so they are on firmware 6.0 from April 17th, 2024. Okay, so that's a pretty current version. Okay. Save the file firmware onto the bundled USB drive. So, they did send a bundled USB. This little guy here. So we'll see if there's anything on it. So it ships with Mark 3.5 firmware, Mark 4, Mark 3.9, 5.1. Okay, so filament guide, rocket engine, RC Sandy Mini. Okay, so it comes preloaded with a bunch of models. That's cool, but it does not have the latest firmware. So we will make sure we download the latest firmware onto the USB. It is Mark 4, Mark 3.9, firmware 6.00. So, make sure we update that. So, I will. Let's see. I will make a folder on here. I know you can't see this. I'll make a folder called old firmware just so I don't delete that one. So if for whatever reason the newest firmware doesn't work, we do have a backup. So that should be all downloaded. That's good. So we will eject. Okay. Then we will be able to plug this in. Goes the other way. It's always, man, that's a friggin' tight fit. Power. We actually need to put power to this thing. Let's see. Do I have a extension cord handy? Because I don't want to plug this into the same circuit as the streaming setup, because that would suck if we drew too much current. Is good. Well, let's see how long this cable is. All right, it's not that long of a cable. Probably 6 feet, 2 meter, or just be under 2 meter, right? So power is off on the PSU. installed. Feels like that should go in deeper. Oh well. So what is the closest outlets I've got here? So my streaming computer is hooked up to a USB or a UPS. And I'm going to be drawing 240 watts. The computer and TV are probably drawing, I don't know, 500, 700, so 240 would probably still be within limits. But I want to get a extension. So I will be right back to grab an extension. Alright, got a heavy duty cable. Let's see if it's long enough. Okay. So I've got a heavy duty cable. This is actually coming all the way from my kitchen island. So this should be on a separate circuit from my living room. Okay. No fizzing, no popping. No magic smoke is escaping. Okay, okay. That's good so far. Let me refill my water while I'm thinking about it. So no magic smoke has escaped just yet. So let's, does it say to turn it on? Okay. Insert the USB with the latest. Connect the power cable and connect the printer into the wall outlet. Turn the printer on using the switch on the back. Okay. So let's see if any magic smoke comes out. Fans on. We got fan spin. No magic smoke's coming out. Hey, the little LCD's coming on too, and it's automatically loading the firmware. New firmware available. Flash. Oh. It's not a touch screen. Hehe. So, after the printer starts up, the setup wizard will show up requiring a self-test. Select Continue to start. The wizard will test all important components of the printer. The whole process takes a few minutes. Some parts of the wizard require direct user interaction. Follow the instructions on the screen. Make sure there's nothing in the way that will obstruct its movement. The wizard starts with the fan check, Z-axis alignment, and X and Y axis test, all fully automatic. All right, well, so far we've got fan spin, so that's good. Put this little doodad on here. Ooh. Okay, select language, English. Hi, this is your original Prusa Mark IV printer. I would like to guide you through the setup process. All right, disembodied head of Josef Prusa. Continue. Fan test, check. Hot in fanned RPM test. Okay, so I've got air there. Checking for switched fans. Fan test in progress. Please wait. So I see a little readout of fan speed on here. That is cool. Okay. Nice. It's moving. Okay, so it's basically just hitting itself into the axis there to check its calibration. During the test, the heat bed and extruder will move in full range. Printer may vibrate and be noisier during homing. Well, she's moving under her own power. That's a success. So x-axis is good. We're checking the y-axis currently. Okay, I heard it slow down. Okay, now z-axis test. Excellent. Okay, load cell test. You will need to help with this test. You will be asked to tap the nozzle. Don't worry, it is going to be cold. Okay, I believe you. Okay, continue. Tap the nozzle on beep. Okay. Okay, okay. Just needed to touch it. So now we're calibrating the Z axis. During this test, the heat bed and move full range printer may vibrate and be noisier than normal. It is alive. So I think this is part of the bed leveling process. It's like a, I think it's called a mesh leveling is what they call it. I'll probably still put my indicators and stuff onto it to make sure that it's square and everything. I see the little red light come on the heat bed. So preparing heater testing, heat break status, heat bed heater check. Okay, so I got some little guys here telling me heat's coming on. Okay, so the bed is going to try to ramp up to 110 C. Dang. They gave me some extra filament here. Okay. Okay, so heater testing, heat break testing. So those passed. So now we're doing the heat bed heater check. Okay, so preparing went okay. So they did also give just 2 small rolls of filament. And I also bought a kilogram spool of the black filament. So I'll at least be able to test if that's working. Okay, so I can feel that heat bed coming on. The gearbox calibration is only necessary for user-assembled or serviced gearboxes. In all other cases, you can skip this test. I did, in fact, install this one myself. I expect we will be needing this. Continue. Before you proceed, make sure filament is unloaded from the extruder. It's unloaded. Okay. Continue. Rotate the screw. Rotate each screw counterclockwise by 1.5 turns. Okay. Interesting. So, by 1.5 turns, the screw heads should be flush with the cover. Unlock and open the idler. Okay. One. 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 This should be flush with the cover. Okay, they're flush with the cover. Unlock and open the idler. Okay. Continue. Gearbox alignment in progress. Please wait approximately 20 seconds. Is it moving in there? Oh yeah, it's moving. She's a moving. Okay, I can feel it move. Tighten the M3 screws firmly in the correct order. They should be slightly below the surface. Do not over tighten. So, 1, 2, 3. Okay. Continue. Close the idler door and secure it with the swivel. The calibration is done. Continue. Filament sensor calibration. We need to start without the filament in the extruder. Please make sure there is no filament in the filament sensor. Continue. Is filament in the filament sensor? No. Insert the filament into the extruder. Come on, give me a free end here. Insert the filament into the extruder until the sensor detects the filament. Okay. Okay. Oh, so I gotta keep it in there. Okay. Continue. Calibrating. Do not remove the filament. Remove filament to finish. Filament sensor calibrated. Happy printing. All right. Use the online guide to set up Wi-Fi. We'll do that later. Because if I have this in the shop, we'll most likely have this on Wi-Fi. Okay. Sensor info, just kind of looking through all this stuff. So we got heat break temp, 28, board temperature, 36, bed temperature, 45, MCU temperature, 43, nozzle temperature, 66, load cell value, it's kind of jumping up and down at the moment. It's kind of hot. Okay, so if it detects a negative value, it's going up. Okay. Interesting. Filament sensor. Okay, so it's reading the raw count on the filament sensor. Okay. Print fan. Yes, print fan is off. Heat break fan is currently at 2600 RPM, so it can go a lot higher because that says it's only at 20%. Heater voltage 0, it's off. Input voltage 24.2. Heater current 0. Input current negative 0.3. Okay. How do I go back? Return. Version info. So, firmware. Yes, we are at 6.0. Bootloader version 234, buddy board 37, serial number, not reading that out, XLCD, got it. Print statistics, fail stats, statistics, return, okay. Settings, filament sensor, stuck filament detection. Stealth mode, don't know what that does. Fan check, input shaper, ooh, I don't know what that does, but that sounds cool. X-axis filters, okay. User interface, sort files by time, print progress screen, menu timeout, sound mode. RGB status. Nice. Touch. What? Touch? Touch. Touch Sigmar. Okay, I don't know what that means. Language and time. Time zone format. Don't care. Network, hardware, firmware update system. Save crash dump, device hash in QR. Okay. Load settings from file, factory reset. Okay. Well, so far everything is working. It passed calibration test. What does this control do? Ooh, move axes. Calibration and test. Ooh, calibration and tests. Okay, so we went through all the tests. Cold pull. Disable motors. Auto home. What is auto home? Ah, so it's just rerunning its 0 positions. Okay, okay. Easy does it. Okay. Ooh, I can move it manually. Nice. Cool, 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 cool. So, the purpose of the printer to make parts out of plastic before they're made into metal? Yes, partially. A lot of times parts can be final just in 3D printed. Like, I mean, the majority of this printer is 3D printed parts, and there's no reason to make them out of metal. Unless you just wanted to. But also, yeah, prototyping parts is something you can do on this. So if you don't want to waste all the time to do the metal programming, or you want to save time in the end to sort of see like the fit and function of stuff, you can print a 3D model before you print a or before you make a full-scale model, just to test the fit on parts. Or, I mean, it's also for like hobby grade stuff where you just want to like make a little figurine or make a, I don't know, something for organization purposes. So that's one of the things I'm going to do a lot is like little holders to hold onto screwdrivers and stuff like that to organize stuff, and just to better help organize my shop. Because I like the idea of being more organized to be more efficient. I just like moving that thing back and forth. Okay. That's cool. I could play with that all day. Temperature, auto home. Return. Filament. Load filament, unload filament. Preheat. Print. Yeah, I don't know what size nozzle this thing shipped with. RC Sandy Mini. So that says it'll take 1 hour, 10 minutes. Chassis interior. Mark 4 IS. 5 hours. I don't want to do that. Body, dashboard, engine, spring. Come on, scroll fast. 7 hours. No way. What is this one? Tires. 1 hour, 55 minutes. 1 hour, 8 minutes. Don't they have something quick I can do? Yeah, this one's 10 minutes. Okay. It says PLA. Bic. 0.4 nozzle. I don't think I've got a 0.4 on here. What did they ship with this thing? I have to... Reward yourself. Add a spool of a sample of your favorite filament. Guide the filament through. Once filament is detected, the printer will load it automatically. It is important to select the correct type of filament you're using on the screen. We recommend using PLA material for the first test print. The print will purge some of the material through the nozzle. Confirm its color is clear by selecting yes. Okay. So I will see how much this can print. Leg cramp. So let's put on this little guy first. No, that is the wrong direction. What? Oh, this is on incorrectly. So I had it right the first time. Okay, so we will load some filament here. So this is PLA, I think. Waiting for temperature. So it's got a 10-minute print on here already. So that's what we'll start with. So it shows my nozzle temperature getting up there. So I don't know what nozzle they shipped with this thing. 3D printers. Is color correct? What do you mean is color correct? Oh. Yes. Okay. So that's a pretty fine nozzle I see on this thing. So I'm just looking at the specs of this thing. Let's see, shipments, build volume, blah, blah, blah. Okay, so it ships with the 0.4 millimeter default. Okay. So 0.4, okay. PLA, yep. So this says it should take approximately 10 minutes to print. So let's select that. Let's print. Oh, so that's what the little reflector does. It helps point these little status LEDs downward. So you probably can't see that, but these little status LEDs. So it looks like it is doing something, maybe? She's moving, she's moving. Okay, so we're having the nozzle at 170C, the bed at 60C. Okay, it's cleaning the nozzle. Oh, okay, okay. I hear the little side fan going now. Let's see. So the bed looks to be up to temperature. All right, she's going. Probing point 1 through of 15. Ooh. She moves quite fast. So here it's using the load cell inside of the nozzle to actually determine the 0 position. Okay, so now it's doing more point probing. Okay, now E heating. Okay, so now it's bringing up the nozzle temperature to 230C. Okay, we're at 215. Okay, so it says we're up to temperature, and it says we have a 10-minute remaining print time. So it looks like it's doing a quick nozzle clean here. Okay, it's printing like a little raft. Oh, it says printing time 3 minutes and 33 seconds now. That's interesting. Now it's 9 minutes. Next change in NA. Okay, that first layer is looking great. Oh, I see. So it's cycling through some different print stats. So print will end NA. I haven't set up the time yet. But yeah, first layer looks fantastic. I don't know if that's supposed to be the first layer or the raft that you normally put down. Leaves a little hanging bit here. So might be hard to see. But it's a little nozzle cleaning doodad. Okay. I'm pretty confident this is not the highest speed this thing can go. I mean, during probe pointing, you saw how fast it jumped around. Oh yeah, look at it go. This is not the most stable surface for it. Probably need to get a granite block just for this to have a stable base. Even though it's a heavy printer by itself, what I've read online before about other 3D printers is putting them on a heavy base like a granite block or even just a steel plate or something like that is enough to help stabilize some of the vibrations in it. So I can probably get a cheap or used granite surface plate to put this onto. So that'll be cool. So then after this, what I'll probably do is we'll probably call stream after we're done with this print, because my inclination is to do some more testing on this as far as like calibration to make sure things are square and parallel. I mean, it has its self-tests in here, but geometrically speaking, from a mechanical point of view, you want to put like a known reference on this stuff and sweep it with a precise indicator to make sure that mechanically this thing is tracking straight and true, so that when in software you don't have to be so or you don't have to have a lot of compensation within the software side. Your software pretty much assumes that you have a perfect geometric state. So I want to make sure that I do have a perfect geometric system, so I don't have weird prints that are like printing off to the side, or things are parallelogrammed when they should be square, and type of things like that. So that process will be very similar to a traditional CNC machine. And that's just kind of boring and tedious, so I won't... it's not as action-packed as, this assembly process here. But I'll probably do that just to satisfy my curiosity of, the machine's repeatability. And then I'll have to temporarily disassemble some of these pieces to fit this into the enclosure, because that's the next thing we have to do once we verify that all this stuff, works as intended. So far, no magic smoke has come out. Everything seems to be working as intended. Is that a little bit of grease, or what is that? It's just a little hanging piece. And then we can actually get to print some cool stuff, like maybe some organization equipment. What else? Definitely some Girl DM meme related items. I'll have to figure out what should I meme print. Should it be a Girl DM figurine? Should it be... I don't know. Oh, cool. Shows a little preview image of what it will look like. Mayo. Yeah. Oh yeah, there is a oh, what is it called? A vase mode, I believe it's called. To where you can do like single walled prints. So yeah, I could make a custom mayo bottle. I see a little hanging piece there, like a little stringy piece. Okay, so this is part of why tension is important on timing systems, because they do have very high acceleration. So if the torque that you generate on the gear is too high, it does have the potential to like skip a tooth. So you do want the tension on these belts to be relatively high, or high for a belt. Okay, says it's got 2 minutes remaining. It's just doing its thing. Okay, and it's not using too much material either. I mean, it's a small piece, so I hope it wouldn't use a lot of material. Because after this, I need to make some lunch, because it is almost 3:30 here. Oh, stretch my legs. That's a nice high quality print though. Yeah, even in the video you can see how much it's shaking the table here. If I feel like doing this IRL setup again, I might think about getting like a soft box for my my overhead light here, because I can see, you know, it's very blown out in the center here, but on the sides it's not as bad. Okay. You know, I am pretty glad that I chose the assemble it yourself version, because it helps me understand more of how this thing works. Oh, hey, we got green lights. Means she's done. Almost right on time, too. 10 minutes. All right. Gets us some statistics. Printing time, 12 minutes, 58 seconds. Okay. Okay, so printing started printing in. It did. Since we haven't established the time, it's the same. Consumed PL. Oh, that's interesting. It gives you a rough estimate of how much it consumed. Okay. A little stringy bit there. So, what did we print? Guess you gotta let it cool for a bit or something. We do have a little stringiness on the part. It's kind of, can't really see it, but I'm trying to twist this without touching. Because I don't have any more IPA. Excuse me, isopropyl. IPA makes me think of beer. But doing the classic sort of, you know, doing this to try to peel the print off. I'm just trying to be delicate without touching the surface. Come on. Peel away. Peel away. Man, I'm going to have to invest in IPA, I think. Sorry. Isopropyl. Come on. Peel off. There we go. Okay. Yippee. So it also printed some little doodads on the side here. I can just pluck those off. Yep. Come back here. So I think this is part of a larger print. Okay, so got like these little doodads. Let me see if I can zoom you in. Okay, so it printed this little piece here. Go to, what does that say? Go to 3dsets.com. So just made that little piece right there. Only took 10 minutes. It's a really nice surface finish on it. And also made these little, I don't know what they're for. Do they fit together? Maybe. No? But I mean, there's a really nice surface finish on this stuff. You can see there is a little stringing on this edge here. Oh yeah, welcome back, Theric. Yeah, we just did our first print. So I don't know what these little, I don't know why it just printed these little pieces here. I guess it comes preloaded with a bunch of different prints you can do, but some of them are like 3-4 hours, so I didn't feel like doing all those, but we accomplished our first test print. I watched Nimona. Oh, yeah. I love that movie, too. Wonder if... is there a way... Are these supposed to be, like, any specific sizes or something? So, that is 6.8 in diameter. 6.8 in diameter. Almost 7. Height. I got a little nub on it. It's about 5 millimeter in height. 5.8. What about this other one here? That is 5.9. Okay. about these little guys? What are these? Those are also 5.96 millimeters. Okay, okay. Man, that's a nice surface finish. I like it. So this was the side that was on the smooth PEI sheet. So you can see it's a really nice surface finish on it. No ads. I don't know what it is. It's basically just, I guess maybe it's like a first test print to say, hey, go to this place and check out this guy's models or something. That's really cool. .3dsets.com/Sandy Gift. That's pretty cool. I'm more interested in the geometrical accuracy of this thing. So this is at 26 or 25.7, 25.8 wide. So I don't know if I'm able to open this model somehow to determine what its design width was, but I'm really happy with how no major stringing on it. The first bed adhesion worked great, or first layer adhesion. So this used no raft on it. Like most 3D prints, you'll see it generate like a small raft and then print on top of that raft that you have to peel off. But this printed without a raft, first time. No major stringing or anything. I mean, we can see a little bit of stringing on here, just barely. But yeah, it looks great. So next steps, let's see, what are the next steps? Let's see, it might be too early for anyone else to be on streaming, especially on a Saturday. Yeah. Okay. All right, I think that is going to be all that we'll do. It's been a long day and I need to eat. I've been running on caffeine and adrenaline of finishing my 3D printer. So we've been almost 18 hours, or 18 hours, 8 hours. But total 16, no wait, this would be 18 hours first time through assembly to get through this, which I don't know what the, high score or lowest score time on this is to complete, but I'm happy that it did the thing the first time at pretty decent accuracy and everything. I haven't been able to do 2 in a bit. Yeah. Yeah, this is the first time I've been able to do a stream that's longer than about 4 hours, and it's mainly because this week at the place that I've been contract work, they have been installing new floors. So I was just like, you know what? I'm not going to come in until you guys finish that because I would rather not get covered in dust and construction crap. Oh yeah, your hand starts to cramp up. Yeah, my back is feeling it right now. Same with my knees, since this table is only about 500 mil from the floor. I made this table many years ago as a sort of like a puzzle table. So it's at basically knee height, so you can place puzzle pieces comfortably from a coffee couch or something. Not so good for knees and being over it for many hours. But yeah, I am going to call it there. We aren't going to raid anyone today because I think I'm going to spend the rest of the day cleaning because my place or my living room right now is a mess. Boxes, bags, everything, everywhere. Not to mention my PC. I'd like to have that back in my office because IRL stream wise, while this stream setup was good and worked, it takes up a lot of space and it means I only have one monitor to actually do the stream on. So I had to keep switching back and forth between streamer view as well as looking at the instructions. So not ideal from that perspective, but otherwise it worked out for what we had to do. Managed to hurt your back a few weeks ago, strained it. Oh yeah. Yeah, that's why it's always good to get up and stretch as often as possible. Speaking of stretching, I need to stand up. Oh, my back, my legs. Everything is about to cramp up. All right. But that will be all for stream. I appreciate you guys hanging out, especially for these 2 long days. I'll probably be back tomorrow to just do normal meme stuff and 3D art. But for now, I appreciate you guys hanging out. We'll see you tomorrow, hopefully, if I don't feel like sleeping in too much. But I appreciate you guys. We'll see you next time. Bye-bye.